Hello, everyone. Hope your weekend is going well. Hope you enjoyed our royalty-free music that we went with for the waiting screen. Hopefully, it feels very professional. That is what we're going for. Hey, Brandon. Hey, Andrew, Jessica, Tall Cat, Chili, Servesh. Uh, got many folks already. The benefit of starting right after ranks is that I get I get to benefit on all of his hard earned people. Uh, hey Jay, welcome. Uh, hey Worm, welcome. Hope everyone is off to a good start. Yeah, this grid does look a bit like a practical joke, doesn't it? Hey SBQ. It does mean I'm gonna have to like rearrange before the next puzzle the layout because I had to slightly change the layout in order to make this fit. Hey Max, uh, but I mean, how could I not do this puzzle? I mean, have you seen this grid? It's quite a grid. Uh, um, By the way, one thing I thought would be fun, and I'll mention this probably several times through today if I remember. I thought it'd be fun to have a little like setting competition, or maybe not competition, but a little setting theme. So I will offer a theme for you to set puzzles to, and then I will do ones on stream. So if you want to submit them, you can go ahead and just drop submissions that meet this theme into the zetamath chat over on the Discord. Link in the doobly doo, as the Greens would say. But the theme for the first sort of like collection of puzzles I'm looking for is Sudoku puzzles without fives in them. And I am setting one this week, so you will see mine in time. But if you want to try and set a Sudoku puzzle with no fives, I am interested to see how you accomplish that and what you come up with. So that will be my thing, and I might periodically do this depending on how many people are interested in designing puzzles to random crazy ideas that I have. So that will be my first suggestion. Uh, let's see. Anyway, thank you again to all of our subscribers. Thank you to Ranks for generously kicking people over here from his stream, which was a lot of fun. By the way, for those of you who enjoy my puzzles, I have a puzzle to celebrate Ranks getting to 1,000 subscribers, which is happening any moment now. If you want the puzzle even sooner, then you should go subscribe to Ranks' channel. I also have plans for this channel getting to 1,000 subscribers. So if you have not subscribed to this channel, I also encourage you to do that. All right, without further ado, let's get started with this because I have no idea how long this is going to take. I think it is listed as 4 stars of difficulty on Logic Masters Germany, but I could be wrong. But anyway, so we've got this grid, and so this is inspired by the Deconstruction by Jay Dyer, I think was her name, that was on Simon a few weeks back. Which I also found quite inspirational, but Math Pesto has made something with this, which has similar rules to something I've been playing with, which is that we have to fill this whole grid with some regions. And so not everything in the grid has to be part of a region. So there could be no digit in this cell at all. That's perfectly fine. But every region has size between 1 and 9. We don't know the region, or we don't know the size, so a region could be just these 4 cells, for example. That could be a region. But if this is a region, we're guaranteed that a region of size 4 contains the digits 1 through 4. Likewise, a region of any size n contains the digits from 1 through n exactly once. Okay. Now, like in a normal Sudoku, you're not allowed to repeat the digits 1 through 9 in any row or column. So we have at most 81 digits in the entire grid, but we could have many fewer than 81 digits, in fact. So this may, in fact, be less work than a... Oh, wait, no, that's not true. Never mind. Sorry. There could be more than 81, right? Because there could be 1 through 9 in every row and column, except that won't work. I'm trying to figure out what the math of this is. How many can I fit into this grid? With just, if I just take the rule that every row and column contains the digits 1 through 9 at most once, how many digits could I get into the grid? Is it 9 times 15? Could I fit 9 times 15? Anyway, this is a complete tangent. We're going to put some digits into the grid. Who knows how many? Meeting these rules. Now, there are a few things that are guaranteed to contain digits. So cells that are on a circle or a square and cells that are on any part of an arrow must contain a digit. So I could not make this digit sum to 1 by putting a 1 here and no other digits on it. That will not be allowed. Although that was basically exactly what I was thinking about before stream started as a way of doing this kind of thing. Yeah, there certainly don't have to be 9 times 15 because the regions, again, could be smaller. And I'm not sure that you actually could fit 9 times 15 in here. Maybe you could. Maybe it should be obvious that you could. But I don't know. But remember, regions can't touch. So regions can never touch orthogonally. So once you have a region here, then you can't have a region here. They can touch diagonally, though, so we could do something like that would be an acceptable way for these regions to kiss. Hey, Busty, welcome, and welcome, Barbie. Yes, I agree with Barbie that there is a digit 9 that is essentially given once you parse the rules. And it is always good to give your solver a little reward for understanding what the rules say. All right. So here is the digit that Barbie sees. So I think I've gone over all the rules. I guess I have not officially said what an arrow means. An arrow, the circle, is the sum of the digits on the arrow. So in this case, the only way this is going to work is if this is a 9. I have to turn my keypad on, I realize. If this is a 9, and these are, well, that has to be 1, 2. Oops, sorry, I'm not in center mode somehow. And these are a 1, 2, 3. There is no other way I'm going to get this to be a single-digit number. And I'm not allowed in this puzzle to invent numbers larger than 9. I'm not even sure what you would call such a number, but you're not allowed to do it. So I get to fill in all of these. And so in particular, the existence of a 9 tells us that there actually has to be a region 1 through 9 that contains this 9. All parts of the arrow must have digits. I believe that was my interpretation. A cell that contains a circle, square, or arrow must have a digit. So this is a cell that contains an arrow, so it must contain a digit, is my understanding of the rules. Okay, so while we're thinking about it, let's go through and figure out other absolute minimums. So this digit here is at least the sum of these 3. So this is at least a 6, 7, 8, or 9. This is at least a 6, 7, 8, or 9. Because it contains the sum of those 3 digits. This one, unfortunately, can only be... this one only has to be at least 5. But I'm not Simon. I have no shame. I'll pencil mark that. Likewise, I will happily pencil mark these 2, 4, 6, 8. Oops. If I can hit 2, 4, 6, and 8, I'm not great at typing. And these odds are 1, 3, 5, 7, and 9, except these two aren't 9 because they're on an arrow. So I can figure that out at least. Now, there are some places where I have some pressure. This one's not a 9 because it sees a 9. 5 grkles puzzles in a row. That sounds like quite a thing. Yeah, I heard you were doing a grkles stream. And so I was like, yeah, that will do your brain in. I try and space out the grkles puzzles in my stream, although I do a lot of grkles puzzles. Okay, so this can't be a 7, because that would make the circle too big, so I'm going to remove the 7. Oops! Ah! No! Don't do that. This cell, that cell specifically, it cannot be a 7. I pointed at it as though that would help. Okay, so this cannot be a 7 because then this would have to be at least a 10, and I can't put a 10 in this cell. This digit's actually already a little bit restricted for what it's worth. Oh, can I enable letters? I don't think I can enable letters yet. I think I would need to go to testing in order to enable letters. But soon we'll have letters. Oh, I don't know. I don't think I do want to... okay, so here's the thing that's cute. Okay, so these two are the same digit, which means they're in different regions. And that means these two cells are empty. So I'm going to put this kind of gray for cells that have no digit in them. So these cells are forced to have no digit because regions can't touch, and these two cells can't be in the same region. And that happens everywhere I have one of these arrows that has this shape. Because all this arrow is really doing, by the way, if you've not seen these sort of short, stubby arrows, as Simon likes to call them, all it's really doing is copying and pasting the digit that is in it from one spot in the grid to another spot in the grid. So we've got all of these hoodiggies. Okay, so does that let us get any sort of start on regions? Well, I know, okay, so actually that tells me, so here's another thing that I guess is good to note. All of these are the same region because there's digits in all of these cells for sure, and they touch. So that also tells me that this is a 1, actually. Yeah, I've been using regions can't touch recently, actually, and I really like it. Let's see. Okay, so these are all part of a region, and it's not this region. So that is actually gray as well, because this region already has a 1 and a 2. So whatever region this is, it can't be that one. We're going to make it blue. The circle under 9 sees 3. Okay, yep, it does see 3. Good point. SPQ. Missed an arrow in column 3. Oh, yeah. Aha, yes, I did miss an arrow in column 3. Good point. Okay, now anywhere there's these long strings of contiguous cells, I want to try and give them a color. There's one over here, too. Oops, that I missed. As I try to figure this out. Okay, all of these are a region. Let's see, all of these are a region. And it's far too big to join any of the other regions, so I can give that orange. There's one up here, too. Good catch, Barbie. I did not a good job of scanning for those, we'll say. Okay, all of these are a region. Or are in a region. Okay, so this cell's in a different region. So this cell can't be red. So this cell cannot be connected to red. And then this is another region. There's another blockages here. Just to explain that again, if this cell was red, then it would be next to a region that we know isn't red, and that's not allowed. All of these are in a region that's certainly not any of the regions we have colored so far, but I'm also about to have to start using bad colors or repeating colors. I guess I'm going to repeat colors. I'm going to repeat and make this blue. Okay, this is in a region. Is it possible that region is red? Yes, it is just possible that this region is red. But this region is not red, whatever that's worth. But I don't know that it has more than one cell in it. Column 2 also has one. Did I get the column 2 one? I think I might have gotten the column 2 one since that was stated. Okay, so... Oh, these are also green. I just missed that. And so now, immediately, because now green and blue can never touch each other... they can only kiss at this little corner. You can make your own romantic story about green and blue. And now green is done. So this goes loop, 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 loop. So now we've got lots of stuff boxed in here. Okay, so now there's a jajillion arrow cells that are in green, in fact. Green contains, approximately a jajillion arrow cells, which is very, very interesting. I could probably do some arrow math. Let's see. Because the minimum sum of these cells is 21. But then you'd have to throw in these, so 23. And so the sum of these three numbers is at least 23. So if one is 9 and 8, one is 8, the other still has to be at least 6. So actually all of these have to be at least 6 in order for that to work. So let me go over that again, just in case you've never seen this kind of logic before. So I'm looking at the sum of all the arrows that are here. Now, the sum of all of these cells that I have highlighted, it is the same as the sum of these three circles. Oh, maybe my 6 was wrong. Sorry, my 6 might have been wrong. Because so the minimum of the sum of these circles is if these are 1, 2, 3, 4, 5, 6, and these are both 1, which would be 23. But then what's the maximum these two cells could be? And I previously calculated the maximum of these two cells as being 8 and 9, but the maximum of these two cells is actually 9 and 9, which says that this cell could be as low as a 5. The maximum of these two, though, is 8 and 9, and so this has to be at least 6. And the maximum of this and this is also 8 and 9, so this has to be at least a 6. Okay, so the only thing I got wrong is I screwed up the coloring there. Or, sorry, I screwed up. This can still be a 5. So we've got that going on. Now, we do know the 9 in box green has to be in one of these two. Sorry, no, it could be there as well. The 9 in green has to be in one of these places. Sorry, one of these places. Is there anywhere that sees all of those that would be useful to know is not a 9? I don't know. Okay, so Tallcat has discovered something that has to be a 6. Row 1, column 2 has to belong to at least a 6-cell region. Good point. Okay, so, yes, so Tallcat has discovered a good thing. As soon as all of these became the same color, this arrow now has to be at least 6 again. So that's because now these three can't be the same. So these are 1, 2, 3, so this is at least 6. Now this digit is at least 6, and so it has to be part of at least a 6-cell region. But this region's definitely not red. And so I want to explore what cells could this region possibly take. And unfortunately, that exploration ends very quickly. Namely, the answer is it can only take these. Which makes Tallcat's beautiful point that this has to be a 6. And so this is a 1, 2, 3, 4, 5 quadruple. Sorry, 1, 2, 3, 4, 5 quintuple. Means this is a 1, 2, 3, 4, 5, except this can't be smaller than 3. This cell now sees 1, 2, 3, 4, 5, so this is a 6, 7, 8, 9 as well. Now, because this is a 6, I know this is a 1, 2, 3 triple. That's the only way to make 6 in 3 cells. And now that means that the smallest this arrow can be is 4, 5. But that means this has to be a 9, because if this was any bigger than 4, 5, then we would be out of luck. Oh, we don't actually know that this is not red. This could be red. Now, we do know these are not red. And how do I know these aren't red? Because the ways to make 6 in 2 cells are 1, 5 and 2, 4, and I already have both a 1 and a 2 in red. So this is not red. This is green region number 2. Now, green region number 2 has to be separated from red. Sorry, green was a terrible choice. Purple. Now, purple region number 2 can't have just a 1 and a 2 in it, because the sum, again, has to be 6. So there has to be at least 4 digits in this region. And so purple has to extend to the right, and as soon as purple extends to the right, it grabs this 9, which means, in fact, purple is going to be a 9-cell region. And now purple and red, again, have to be forever separated from each other, as tragic as that sounds when you put it that way. And so there's a gray here. By the way, red and yellow are not the same region, so they have to stay separated. So this is going to go over here, like that. Yes, this is very cool. This is a shoo-in for me recommending to Simon, although who knows... My records with recommending things to Simon are mixed, but this is sweet. So yeah, this is very snappy and cool. Okay. So there is no way that purple doesn't take this cell, because remember, purple is not allowed to take any of the cells that border blue, and purple needs to take 9 cells. So purple is going to need to take this cell to get out, which means it's going to have to take that cell to get out, which means these 2 cells can't be anything. Now, there's no universe where this is a color other than purple, because if this was a color other than purple, purple would end here, and then purple would be capped at having 7 cells. So, in fact, this cell has to be purple, which means this cell has to be purple. Purple now touches this cell, so this cell has to be purple. And just like that, purple is done. And so none of these cells can be purple. Which also means that while we weren't paying attention, red finished. So red, in fact, is a 6-cell region. Okay, oh, and this is not purple. So this is a 1-cell region. Because it has to be a region. But it can't be any color, but it can't expand any other things. Wait, Zeta, couldn't purple have been blue? Oh, no. Okay, wait. Blue. We got to rewind all the way back to, to here. Yeah, maybe purple can be blue. No, purple can't be blue because 1 of 1 or 2 is on this 6 arrow, and blue has both 1 and 2. Okay, so... good catch. I absolutely did not even think about that a little bit, but it can't be. So we're going to make this a rogue black 1. No, that's gonna lead to problems. A rogue orange 1? Sure. Okay, now that's very interesting, because this 1 looks back at this blue arrow. Now this arrow needs to sum to at most 5. Well, the only thing it can possibly be now is 2, 3, with this being a 5. So that's a 5. This is not a 2 anymore. These aren't 5. Now I've got a 1, 2, 3 triple in column 3, which means the minimum that these 2 cells can be is 4, 5. And so again, they have to be 4, 5, making this a 9, making that a 9. By the way, all of these are part of a region. But I don't know if that region is blue or not. Yes, the 5 sees a 4 in the same region, Barbie points out. Good point. So that's a 4, that's a 5. Thank you, Barbie. Now, I'm trying to decide if this cluster has to be the same as blue or can't be the same as blue. Let's see. Okay, could this arrow possibly be in this region? So if this arrow were in the same region as all of these cells, then the absolute minimum I could put on this would be 1, 6. which would make that a 7. I guess that's possible. Oh, right. 57 Thorns has the right way to look at this. Blue doesn't have a 1 yet, so it's got to take a 1, and the 1's going to go in one of these places. And no matter where the 1 goes, well, it's going to go in one of these places or lower, and no matter where the 1 goes, it's going to connect. So this is going to be blue. And then blue is going to be done with whichever one of these cells it takes, because blue only gets 1 more, and these have to connect because these are the same blue. So that's not connected. I didn't articulate that super well, but the point is blue could not be done because blue needs a 1. And so blue had to grow, but the only places blue could grow were here. And whichever of those blue took, it was going to connect it down here. This was SPQ's point. Okay. Now, if there's not a 1 on this arrow, what is that going to do? Well, then this is going to be a minimum of 6 and 7, because 2, 3, 4, and 5 are already gone. So there's definitely a 1 on this arrow. And that 1 is joined by either a 6 or a 7. It can't be joined by an 8 because there's already a 9 in blue. I know this is 6, 7, 8, or 9. In fact, I know this isn't 9 because it's sharing the region with green. I know this isn't 9 because it's sharing the region with a 9. Sorry, I did not put a 1 here, but SPQ points out there's already a 6 here. It's not as exciting as it was going to be a second ago when I had mispencil marked the column. There's already a 6. This could never have been a 6 anyway, but there was already a 6 up there. This was already going to be either 7 or 8. Okay. Now, I can't use 4 or 5 as part of this this hoodie. Good point. Okay. Tristan points out column 1 already has a 1. In fact, I know that's a 1. Not sure that does a whole lot, but it's true. I feel like I should be able to figure out what this arrow is, but also there's so much going on here that I feel like there's a lot I could figure out without resorting to that necessarily. Okay, what is this cell? It's not 1, 2, 3, 4, 5. It could be 6, 7, or 8, and it's not 9. So that's right away 6, 7, or 8. Let's see. These are at least 2 and 3, so this is at least 5, owing to the 1 across here. Let's see. There's a 1 and a 2 looking at this arrow, so this is at least 3, 4, 5. So these can be from 3, 4, 5, 6, but that means that this is at least 7. And could be 7, 8, or 9. This cell goes here, so it's not a 9. This is a 6, 7, or 8. And that means there's definitely a 1 here, because I can't make a number 6, 7, or 8. I can't make it without a 1. Okay. The absolute minimum that these sum to, these 5 cells I have highlighted, is 15, which means the sum of these 2 digits has to be at least 15, which means that because this can be at most 8, this has to be at least 7. So this is actually 7, 8, or 9, just by that sort of consideration. Let's see. Where does 6 go in blue? Asks Tristan. Good point. And I think that Tristan was repeating Oddly Even's point. Yeah, Oddly Even had this point. Where does 6 go by blue? Well, blue has a cell in one of these two, but it can't be the 6. So in fact, the 6 in blue has to go exactly here, which makes that a 7. And so what is the digit that blue is missing? Blue is missing an 8 that needs to go in one of these two cells. So one of these two cells is a blue 8. This cell, by the way, this is the cell that Tristan mentioned earlier that I could gray a cell, one more cell. This cell can't be anything. Okay. All right. I know that this is a 1 or a 2. Because again, 6 is either 1, 5, or 2, 4, and this can't be a 4 or a 5, so this is a 1 or a 2, and this is a 4 or a 5. And it's not a 4, so it's a 5, which makes that a 1, which is very handy. Which makes these at least 2, 3. So I want to experiment for a second and ask myself if these could possibly, in any universe, not be 2, 3. So if these are not 2, 3... the next thing they could be is 2, 6, because 4 and 5 are already gone in green. And that's way too big, because 2, 6 plus 1 is 9, and there's still a whole other cell that I have to fill with a digit that can't even actually be 1. So these are 2, 3, for sure. Because they can't be 1, because there's a 1 looking over here. Which means, actually, if you look at it now, I can't use 2, 3, or 4, 5 to make this 7, so this 7 must be a 1, 6, which gives us a digit here that's a 3. These aren't 3. Now, what is this arrow actually summing to? 2, 3, and 1 is already 6. This digit can't be a 1, because there's a 1 in purple already. So it actually, because this digit's not allowed to be a 9, this has to be a 2. Making this sum 8. And making that digit an 8. There's a whole hoodiggy coming down here. Now, this hoodiggy that's coming down here, it can't be purple anymore, because purple's got way too many cells. So this is going to be another yellow hoodiggy, which is going to immediately gray these, because I can't let these merge. These are gray because I can't let yellow and orange merge. This has actually been a breeze so far, Kodak. This is, I looked at this and I was kind of like, well, there's a chance that this is a puzzle that takes the whole stream. But actually, this is, we're less than 30 minutes in, and look how much we've got filled in. So I think this puzzle is actually, the difficulty is just pitched perfectly for something that looks like it's going to be terrifying. I see this can't be a 1 because there's a 1 in the row. I see that can't be a 1 because there's a 1 in the row. I see this can't be a 2 because there's a 2 in the region. Yes, very fun. This is an incredible experience so far. I am all on board for this. Let's see. Okay, so what digit is actually left in green? Because green only has one digit left, right? 1, 2, 3, 4, 5, 6. Okay, yep, 7. This cell's a 7. So that cell's a 7. And so as soon as this cell's a 7, it has to come out, which means it's going to have to join yellow. Because it can't come out without touching yellow. 1, 2, 3, 4, 5, 6, 7. So that's 7 total cells. So yellow's still going to have to take at least one more cell because we know it has this 8 in it. By the way, this is not an 8 anymore. By the way, now this line now also requires a 2, and I'm now noticing that this has to have a 1. So ergo, this is a 6 and a 1. And that fixes that this is actually a 7. Which now fixes that this is a 1, 2, 4. So now the minimum that this line could contain is 3, 5. And so it has to contain either 3, 5 or 3, 6. But it definitely contains a 3, which fixes our 2, 3. By the way, Kodak, if you're interested in joining my puzzle challenge, my puzzle setting challenge is to set a Sudoku puzzle with no 5s. I'll probably do all of the submissions that people make a week from Wednesday is my plan. So if you setter folk are interested in making a puzzle with no 5s to see Zeta do it, then I will do it. No one likes 5s anyway. Orange has to grab this 7, of course, because it's already touching it. So therefore, this digit can't be a 7. Also, this digit could never be a 7 once it had all the digits marked on it there. Yes, that is the challenge. Make a puzzle with no 5s, and I will do it on stream and on the no 5 day. Alrighty. How you make a puzzle that is a Sudoku puzzle with no 5s, that is totally up to you. I did specify it has to be, in some very broadly construed sense, a Sudoku puzzle, just so that I did not get a million simple loops to be like, simple loops don't have 5s, or whatever other puzzle genre. There's a 6 over here. Not, by the way, that I don't love pencil puzzles, but it's not much of a challenge to design a pencil puzzle that doesn't have a 5 in it. So this is an 8. Chat was telling me about that. 2, 3, 4, 5, 6. Okay, there needs to be a 6 in orange. 6 can't get an orange in this... Sorry, orange can't get a 6 in this row. It can't get a 6 in this row. It's not getting one here. In fact, this can't be a color. So the 6 that orange is getting has to be up here. Right? 1, 2, 3, 4, 5, 6, 7. Yeah. Orange gets at most 2 more digits. I guess technically orange could take a 9 in one of these 2 cells and then a 6 up here, or a 9. Oh, sorry. There's even room for 6 in this row. Don't listen to me. I don't have any idea what I'm doing. So what's this digit? It can't be 1, 2, it could be 3, it can't be 4, it could be 5, but it can't be 6, 7, 8, or 9. So this is a 3 or a 5. That's a 3 or a 5. Of course, it helps if I copy the right digit. I am told. Let's see. All right, so now as is being pointed out by, I think Barbie is the first one to see this. This arrow now, if it was going to be an 8, it was going to have to be a 3, 5. This is a good spot, by the way. This is much harder of a spot than most of the things have been in this puzzle. If this was going to be an 8, this needed to be a 3, 5, and it can't be anymore because it's looking at a 3, 5. So this now, that doesn't tell me what this is, but it tells me that that's a 9. Now, this over here, I know, is not the 4, 5 kind of 9. It's not the 2, 7 kind of 9. So this is either 1, 8. Yeah, this could be 4, 5. It's either 1, 8 or 3, 6. I don't think I know which one it is yet. Let's see. I do have here a region that can no longer be purple, because purple now is at peak cellage -1. Purple needs 1 more cell, but it can't take this cluster. So these are gray. These are part of a region. You can have another green region. Could I do math to figure out what this is? So this is 9. That's 27. That 7, therefore, is 34. So the remaining cells in purple add up to 11. But this is only 2 of the 3 remaining cells, so this digit is at most 11. Okay, that was maybe not the most helpful exercise that I've ever done. Technically, actually, because the remaining cells add up to 11, I know that these add up to at least 3. So this is actually at most 8. Oops. 3, 4, 5, 6, 7, 8. Could these possibly be a 1-2 pair? I think annoyingly, yes. I think they could be a 1-2 pair. Let's see. Where else do I have things happening? This 8 is looking over at this square and saying that's not an 8. Green has grown into this arrow. I did not notice. Making a lovely 4-shaped region. Now that's going to be very interesting. Because now this is at 7 cells. So now these 2 arrows need to total to at least 15, because these 5 cells total to at least 15. So the most this can be is 9, so the minimum this can be is actually now a 6. So yeah, this is a 6, 7, or an 8. Why is the arrow circle in green not a 9? Because I can't do math, I think, is the answer. I think it can be 9. I think I calculated the complement of it by accident. Yeah, I don't think I did that correctly, so I think you're right. I think this could be a 9. Good point, SBQ. There's a 7 and a 9 looking over at this circle that has not gotten to play with us in a while. So if this is a 6, this has to be a 1, 2, 3. The 3, 5 cannot be a 5. I'm trying to figure out which of the 5. I will see. I'm now scanning chat for a bit. Pencuri noticed this 1, 2 pair looks at this and says that that's a 3 and that's a 2. I agree with that. Let's see. 3, 5 cannot be a 5. Which 3, 5? The arrow tip cannot grow to be a size 5 region. I don't know where we're talking about. The not colored 3, 5. This one. Okay. Got it. Okay. So this cell, Naverio is saying, okay, so first of all, this cell can't be orange because orange already has a 3 and a 5. So first of all, let's put in a wall there. Okay. Next, could this cell be yellow? And I think the answer is, by the way, this yellow, not this yellow. I think this cell could be yellow, can't it? Well, I mean, whatever it is, this region has to grow up quite a bit. Okay, this has to be yellow, in fact, is the point. This has to belong to this yellow. Because the smallest this could be is a 3. Yeah, so let's imagine we tried not to make... let's say we try and make this cell not part of the yellow region. Then what's going to happen is I'm going to have to not let it touch the yellow region, which means it's going to have to take at most this many cells. Now that's going to make this digit a 3, and it's going to mean I need to put a 1, 2, 3, and 4 in this region. But there's a problem because I would have to put one of the 1 and 2 in this row, and I already have a 1 and a 2 in this row. So that's not going to work. So this cell, and I think this was, this is what Naverio, I think, was trying to tell me, is that this cell is yellow. I kind of want to make this a different color just to make more clear what's happening. We're going to make these red. Am I wrong? And now there's no way that these connect without this cell being red. 4, 5, 6, 7, 8. In my head, that was the opposite of what I thought Naverio was arguing, but I just I just skimmed because I'm not good at reading. I have a 1-2 pair in row 4, so this is not a 1 or a 2. Or a 4 for that matter, because there's also a 4 in the row, so this is a 3, so none of these are 3s. That 6 is seeing down there that that's not a 6. Let's see. This region's going to have to be quite big, because it definitely has a digit in it that is at least 7. No, not a problem. I was just checking to make sure I didn't screw something up. This can't be an 8, so that can't be a 1, just owing to that 8. Let's see. Now, because this is not a 9, when did this become not a 9? Yeah, because this isn't a 9, remember these two have to sum to at least 15. So because of that, this being an 8 at most means that this is at least a 7, so I can at least rule out that this is a 6. It's not a 6. Let's see. Carl has a good catch. The region that the bottom left arrow belongs to must have a 1. And it can't get it before column 7. Let's see. Okay, so 1, 1, 1, 1, 1, 1. Yeah, so this column, which is, as claimed, column 7, this is the first column that can possibly have a 1. So, therefore, this little region is going to have to be the little region that could. It's going to have to grow all the way over to column 7. Now, in growing to column 7, it is definitely going to have to merge with this arrow. Sorry, it's 1, 2, 3, 4, 5, 6, 7. So I have to get at least that far. Oh, sorry, I don't have to do it that way, though. These, however, are orange, and it's the same orange that's over here. I think it could just do something like that and not take this cell, I think is okay. But yeah, orange is going to take a 1 in one of these cells. Or maybe over here, even. If the world is... No, I don't think... Orange can't get here, because if orange gets here, it doesn't take that cell, and now this cell doesn't have a region to be home, to be friends with. Okay. So yeah, good spot, Carl, on that. 4, 5, 6, 7, 8. Okay. Red is currently 8 cells. I guess we don't know what region... Or sorry, what color red is missing. Or sorry, what cell red is missing. We do know red is missing a cell, though. Let's see. Purple. Purple also is missing a cell. Let's see. What digits are left in column 3? That's a good question. 1, 2, 3. Let's see. We have a 4. No, we don't have a 4. 4, 5. 6 is the only digit left. No, sorry, not 6. 8. 8 is the only digit left in column 3. Which means there could be a blue 8 here. But I don't think it means there can't be a blue 8 here, because the column doesn't need an 8. It just could have an 8. And this column could also have an 8. Oh, wait, no, sorry. there's only I understand the point now. There's only one cell left, which is an 8, which has to go to orange because orange is not getting here by teleporting. Orange has to cross the threshold of column 3. So 2 points come from that. One, you'd think Math Pesto set the puzzle or something that they saw this, but one is that that's an 8, and the other is that that's not an 8 because in column 3, the 8 is orange. One of these two is an orange 8. Okay. This is nothing. What about this column? Let's see. We have left 2, 3, 4, not 5, 6, and then we got a 7, 8 or 9. Okay. So we're either making 9 as 2, 7, or we're making 7 as 3, 4. And those are the options, weirdly enough. Let's see, what about this cell? What is this cell allowed to be? 1, 2, 3, 4, 5. Could be a 6 or a 9, I believe. I'm just looking at the column. What about this cell? This cell can not be 1, 2, 3. It looks like it could be a 4. Can't be 5, 6, 7, or 8. And it can't be a 9. This cell is a 4 by force. This is a weird naked single. 4 is the only digit that can go in this cell. I don't know that does us any good, but it's true. It's a digit. And digits is digits, as they say. 9 in column 5 must be orange. What if there is no 9 in column 5? Do we know there has to be a 9 in column 5? Oh, column 4. 1, 2, 3, 4, 5, 6, 7. Right. Okay. Beautiful, beautiful. So Nathan was asking about the 8s. Okay, and so this is going to be a good chance to repeat the explanation of the 8s and then explain why there has to be a 9 over here. So orange has to make it through to this orange. And I don't know what path it's going to take. But the thing I know about the path is it's definitely going to take a cell in this column and a cell in this column. Well, because I'm not allowed to repeat numbers in columns, and every digit except 8 has already been used, the orange that goes through this column is going to have to be an 8. Likewise, in column 4, the only digit that's not been used is a 9, and so the orange that goes through here is going to have to be a 9. And that's going to immediately mean that that's a 7, and that's a 6. And so this is going to be a 3, 4. Now, this is going to have to be a 1, 5 way of making 6. Now, this can't be... wait, sorry. No, I don't know that this is entirely contained in orange. Don't listen to me. So 6 is either 1, 5, or... So this I can say. It's either 1, 5 or 2, 4. But we already have a 4 in orange, so this is not 4. And there's a 1 looking at this. So if this is a 2, then this cell's a 4 and it's not orange, which seems unlikely, but let's follow this for a second. Otherwise, this is a 5, and this is an orange 1. Let's investigate the possibility that this is a 4 that's not orange. Because if this is a 4 that's not orange, orange still needs to get a 1 in this column, which is going to have to do exactly like this. But then this could be a region that looks exactly like that. Is that possible? Can I have a 1, 2, 3, 4 tetromino? Can these be 1, 2, 3? Unfortunately, I don't immediately see... no, they can't because of that. Wow, okay. This doesn't work. This does not work. So if orange tries to make a 4 here... Sorry. if there needs to be a 4 here if this is a 2. But that's not possible, because if there's a 4 here... Oh, good night, Codec. Then these would have to be a 1, 2, 3, because these are the only cells that this could occupy, but they can't be because there's a 1, 2, 3 triple already looking down on it. So that means that that's a 5, that's a 1, and is orange. Because there's no way orange goes through 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no way orange has a cell left to give in order to take a 1 further over. So that's a 5, that's a 1. This is orange. Let's see. Oh yeah, I wasn't sure. Someone in chat said you were solving the region sum lines puzzle. Someone in chat said you did finish it, but that it took you 5 hours. But it sounds like maybe you did not actually finish it and did a different puzzle instead. Yeah, I was curious about how that would go. Okay, so this can't be a 7 anymore, because now it sees a 7 looking across it. This can't be a 5, because it now sees a 5 looking at it across. So, can I do better than that? Let's see, 3, 4 pair in row 14 is a phrase that I do not often aspire to see. Isn't this row 14? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think this is row 14, but I don't see a 3, 4 pair. The green 3-cell arrow has to be an 8. Because if this were 1, 2, 3... okay. If this were... So here's why. And this is a little complicated. This is a really good spot, by the way. I think it was Barbie who saw this. If this was a 6, it would have to be 1, 2, 3, which would force this pair to be 4, 5 with a 9 there, because that's the absolute minimum I could make it, but it's also the maximum this could be, but there's already a 5 here. So it's not that way. So this is an 8, and that's a 9, which tells us this isn't a 1, because it would need to go with an 8, and this isn't a 3 because it would need to go with a 5. Oops. Yes. So this is a 7 going with a 2, which tells us that our 8 is a 1, 3, 4, because that's the only other way to make 8 that does not use a 2. So that's not a 1. Let's see. Okay, so now this is a 9. So excellent job to whoever pointed out to me that I was not accurately considering that this could be a 9, because it definitely could be a 9. Okay, so what is this? So it's not 1, 8. It's not 2, 7. It could be 3, 6. And it's not 4, 5. So it is 3, 6, which means these aren't 3, 6, which means that this is a 1, 8 in that order. These aren't 3, 6 anymore. So these are 4, 5, which gives us that that's a 3 and that's a 5. Let's see. That is large. Let's see. Yeah, green can still take this cell, I believe. This cell's not a 1. So now the question is, can green not take this cell? And I think the answer is no, because now that this cell can't be a 1 anymore, if this cell is not green... Sorry, now that this can't be a 1 anymore, if this cell's at least a 3. If it's not green, it has to find 3 cells to take, and there aren't 3. So this is green, which means that green actually finishes by taking one of these 2 cells, which means none of these cells can be anything. Let's see. And because this is green now, it's not 7 or a 9, and it's not a 3, so it is in fact a 5. And the remaining digit for green is 6. So that means that green needs to connect through here because green needs to take a 6, and it can only take the 6 there. And now green is done. So those all turn gray. Let's see. The green 2 in row 14 looks back at the orange and forces the orange 2 to be in row 15. Okay, so this is a good point. So yeah, so orange needs a 2. It can't get it in this column because there's already a 2 going in this column. So orange needs to take a 2 in a cell that's not one of those cells. So it needs to take it. Yeah, it's not that cell either. It's not that cell. It's not that cell. So yeah, orange needs to take a 2 in either this cell or this cell. Or it takes one up here, which I've lost track of the counting of how exactly that worked out. It's possible we could work this out, but I don't know which of those 3 is a 2 immediately. Because why can't this be the 2? Does it not work? Do we not have enough cells? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we do not have enough cells. Okay, so that's not the 2. So yeah, the 2 is in one of those 2 cells. It's either there or there. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what about this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there any way that it doesn't take it here? I think orange... Yeah, I see that Chili is saying the same thing. I think orange has too few cells left to not take this cell. Anywhere else orange tries to take the 2 is a detour, and any detours will stop orange. So orange currently is already sort of at a minimum 1, 2, 3, 4, 5, 6, 7, 8 cells. So really orange only gets to take one of these 2 cells to finish, and the one it has to take is actually this one. And so for the same reasoning, that's the 8, that's the 9. These are orange, and that's orange, and all of these are nothing. Now this cell can't be anything because it's it would have to be a 1 if it were anything, and it can't be. The cells here would have to be a 1 or a 2 if they were anything, and they can't be. Let's see. The 1-2 pair in row 3 gives us a bunch of digits. Okay, I do not have a 1-2 pair in row 3, which means I'm missing something. For example, I am missing the fact that there's a 3 looking over at this. So once I realize that this 3 looks over at this, then we have a 1-2 pair looking over here, which means that's a 4, that's a 2, that's a 1. That 2 looks back over here and says that's a 3. So that's a 2 and that's a 1. That 1 comes back over here and says that's a 2 and that's a 1. That 1 looks over here and says that's a 2 and that's a 1. And as promised, we have gotten a great many digits out of that observation. This isn't a 4 anymore. Okay. What is left in purple? We still need a 3, 4, 5, 6, 7, 8. It's a lot of digits. Let's see. This is not a 3 or a 6, though, or a 5. This is a 4, 7, or 8. This is not a 6, at the very least. This one's not an 8 either, because of the column. Yeah, this is not a 6. I think that's the best I can do. This one's not a 4 or a 3. So where does the 3 go in purple? 3 in purple can only actually go here. because purple needs a 3. And so now that's a 5 and that's a 5. There's already a 5 in purple. Oh, how about that? So I don't have to consider the case that that's a 5. So now where's the 4 in purple? My sources are telling me the 4 in purple only goes up here. So that's all cool. Got a 6, 7, 8 triple down here. Let's see. 5 in red sees the 5, 7 cell. I don't know. I think that was what was here. Let's see. What about this? What can this be? It can't be 1, 2, 3, 4, 5. Looks to me like it could be 6 or 7, but it can't be 8 and can't be 9. So this is a 6 or a 7 by itself. Let's see. What are these cells? Let's see. They can't be 1. They can't be 1. So this is at least 2, 3. So this is at least 5, but it's not 5, it's not 7, and it's not 8. So it's 6 or 9. But it can't actually be 6. Oh, maybe it could actually be 6. Sorry. Can this be 2, 4? I think this can be 2, 4. Let's see. If this were a 9, couldn't be 1, 8. Couldn't be 2, 7. But this could be 3, 6, I want to say. Yeah. Couldn't be 4, 5, though. So this is either a 3, 6 if this is a 9, or it's a 2, 4 if it's a 6. And so if it's a 2, 4, that's not the 4 and that's not the 2. And if it's a 3, 6, that's not the 3, and so that's not the 6. So this cell is always a 2 or a 3. This cell is always a 4 or a 6. Notably, if yellow takes a 9, that means it does have to do... Tristan says there's a 9 in the column, which is helpful. Because if there's a 9 in the column, then guess what? This is not a 9. So, okay, so those are not 6. So we've got a 6 there. Okay, so now this cell... Oh, no, yellow has to take another cell. Well, yellow has to take a 1 somewhere. Actually, yellow can't possibly get to a 1... Sorry. Yellow could get to a 1 in one of these two places, right? One of these two is the yellow 1, I believe. Yeah, I believe one of these is the yellow 1. I don't believe I know where. But let's go ahead and fill this in. This could be a 1. No, it can't be a 1. 2, 3, 4, 5, 6, 7, 8, and 9 are the options. But this is not a 9. So in fact, actually, this is just a naked single 3 once you actually write out what it could be. So yeah, yellow is missing a 1 and optionally a 9. But yellow can't have a 9 because no cell yellow can get to can have a 9 in it, right? Yeah, yellow can't get to a 9 because 9s are blocked off from all the cells that yellow can possibly get to. So in fact, yellow gets a 1 here and finishes, is what happens. So those are gray. Red already has a 5, says Basti. I believe that. Okay, so that's excellent. So Basti has a good spot. Red has a 5, so this is a 7, which means that's an 8, that's an 8, that's a 6, that's a 7, that's a 6. Which is just sort of like a veritable apocalypse of filling in digits. Red still needs a 3, I am being told. So... any cell that can't be a 3 that's adjacent to red just can't be anything but gray. Can't belong to a region. So none of those can belong to a region, because they can't be 3, and 3 is the only digit. So now red has to take a 3 in the only place it can, and now red is finished. That 3 looks down and sees that that's a 6 and that's a 3. This 5 looks over and sees that that's a 4 and that's a 5. This 4 looks over and sees that that's a 3 and that's a 4. This 3 and 4 say that's a 1. This is not a 1 or a 4, so it's a 3 and that's a 4. This has for a super long time not been able to be a 4. But we don't talk about it. Let's see. Purple, again, still needs a digit. What's the digit purple needs? Purple needs a 2. So same logic as with the red. Anywhere that can't be a 2 that touches purple just can't be anything. And so purple actually can only take its 2 exactly here. And now purple is done. Let's see. These gray squares that are isolated and can't contain a 1 are isolated and can't contain a 1. So they are kaput. Yellow, we said, is done because yellow can't actually take a 9. So this cell is nothing. 2, 3, 4, 5, 6, 7. Yeah, orange over here needs a 6 and possibly a 9. I can notice that these cells can't possibly be a 6 or a 9, so they are grayed out. Because there's a 6 and a 9 in the column. Let's see. Yeah, let's see. Yeah, if this were orange, it would have to be a 9 with that being a 6. But that still seems hazily possible. There's a 6 and a 9 in this row, so that's definitely not orange. Let's see. This row has a 1, 2, 3, 4. The 4 looks over here and sees that that's a 5, and that's a 4, 6, 7, 8. So this row can either have a 9 or have nothing. So this is a 9 or nothing. So orange could take a 6 here and a 9 here. I believe that would be okay. Let's see. I'm told about a red 6. Yes. Stephen, by the way, welcome Stephen and Ben and Josh, who I don't think I've welcomed yet. This 6 looks right, says Stephen, which is a good catch. So that is a 2. So it is a new region. It is not part of orange. Orange already has a 2, and it's not part of blue for take your pick. So this can be a new yellow region. The orange 6 only has one place to go. It could go here, or it could go here. I think orange 6 has more than one place to go, unless I'm missing something, which is very possible. But it looks to me like orange could go 9 and 6 up like that. Or orange could go 6 here and then optionally a 9 here, which would probably be a uniqueness problem, but I'm going to try to think not too hard about uniqueness in a puzzle genre that I have not done before. Okay, so 1, 2, 3. Okay, this column is missing. Well, sorry. This column does not have a 3, 4, 5, 6. But we could have a 7 or whatever. So there's lots of stuff going on there. 4, 5. Let's see. The only digits left in this column are a 6 and an 8. I'm trying to figure out if we can somehow claim that this blue can't possibly get out. Yeah, we have to. Naverio is also noticing that we have to somehow resolve the puzzle, which is seeming like it's gonna be a big ask. I would love to be able to box blue in or force blue to take a digit or whatever. Because Yeah, somehow the... Yeah, Derek has a good idea, which is to find a spot in the grid that sees every digit, and so has to be gray. So let's see. So maybe I should just gratuitously pencil mark things, and we'll just remember that these pencil marks I'm writing in could be nothing. Actually, I'll pencil mark it as 0, just to remember it could be nothing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is not an 8. This is not a 9 or a 7. This is not a 7 or an 8. This is not an 8. This is not a 7 or a 9. This, disappointingly, could be just about anything its little heart desires. This is not an 8. Remember, we can have a whole lot of zeros, so there's no, like, no weird singles or anything. No weird triples or anything like that. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this cannot be a 4 or a 5 or a 7. This can't be a 7 or an 8 or a 5. Close. This can't be an 8. It's disappointing. This can't be a 7. You have also let yourself down. This can't be a 4 or an 8. Oh, I should be looking. I should be counting ones. So I should be looking at ones and ask, okay, how many more ones can there possibly be in the grid? There has to be 1 for yellow. And that's it. There has to be 1 for yellow, but I can't put any more 1s up here. And so I have a yellow region. I have the blue region, but I can't fit any more regions up here. I mean, I still think we're going to have to do this, because I think we're going to have to argue that blue can't get away. Because, I mean, knowing that... So, what we've learned from looking at ones, to be clear, is this cell is not part of a new region. It is either part of yellow or part of orange. Yellow needs to take a 1, and it needs to take a 1... in one of a handful of places, like there or there, one of these two, I think. Or I think these are the only places that yellow can take a 1. This, by the way, this is not a 2. But we somehow have to box blue in, so we have to figure out that there's a digit that blue could never take. I don't know what that digit is. It doesn't look like blue can ever get a 6. Interesting if true. So blue would have to get down to this row at least in order to get a 6. Could blue take a 6 here? 1, 2, 3, 4, 5, 6, 7, 8. It looks to me like blue could take a 6 here. What about 5? Yeah, blue could take a 6 here and a 5 here, it looks like to me. Okay, but I think I want to pencil mark the blue ones before we get to... the yellow ones before we get too up into this, which is that the the yellow ones, I think, can only go in one of these two cells. By the way, this isn't a 1 either. Just by, like, a regular Sudoku pencil marking that I maybe should have done before I started trying to pencil mark literally everything. But whatever, pencil marking everything is also a good strategy. Question mark. Let's see. Okay, so what about 3s? So can yellow possibly take a 3 anywhere is next my question. Let's see. If yellow wants a 3, yellow has to get it from Yellow just can't have one. So yellow, in fact, actually can never have a 3 anywhere. There are too many 3s placed. So yellow can't get a 3, which means it has to get its 1 here. So that's yellow. And yellow is now done, which grays all of that nonsense. We can yoink that out. Okay, which means this cell has to be orange. So that's a 6 and that's a 9, and orange is done. Gray. That's done. This can't be a 1. This can't be a 1, maybe, possibly. Yes, this can't be a 1. Also, that's a 4. That's a 2. That's a 1. So now the question is, have we now made blue unable to possibly get a 6? Because now, in order to get a 6, blue has to make it down to at least this cell. This is the closest cell to blue that blue could get a 6 in. And I don't think blue can get there. 2, 3, 4, 5, 6, 7. Yep, blue is too far away. So now, blue is done, because if blue takes any more digits, it has to take an 8 in order to even escape here, but it can't get a 4 anywhere close by. So blue is actually done. All of these cells are, in fact, gray. And these, I can delete the pencil marks. And then we hit tick. Uh-oh. It doesn't think we got it. Why ever does it not think that that this is correct? I don't understand. Very nice puzzle. Very nice. I really enjoyed that one. I'm going to take a very quick break. While I take a break, you can enjoy our royalty-free break music. I'd like to, again, thank the patrons. Thank the subscribers. Please subscribe if you've not subscribed yet. Please also consider subscribing to Rank's stream, because I want to give him his 1,000 subscriber birthday present, but I can't give him his 1,000 subscriber birthday present if he doesn't get to 1,000 subscribers, because it feels a little bit unfair. I don't know. Anyway, so subscribe to me, subscribe to Ranks, like the video, all the good stuff. Consider becoming a patron at patreon.com/zetamath. I'm delighted how many of you have already become patrons. And also consider... Well, I don't want to get to 1,000 subs before Ranks. I just want Ranks to get to 1,000 subs so that I can give him his 1,000 subscriber birthday present. But anyway, enjoy the Be Right Back music. Enjoy sleep if you are like 57 Thorns and you are now going to sleep. But I will see you all shortly. And by the way, just as a reminder, I did offer a setting challenge. I'll do all the puzzles that meet this setting challenge a week from Wednesday. The setting challenge is Sudoku puzzle with no 5s. Anyway, all that said, be right back. Welcome back. Wow, actually that seems not to have destroyed the layout. Because I had to obviously change the layout a lot for the previous puzzle, I was expecting when I came back that this would be a giant mess, but it does not seem to be that much of a mess. So what do people think about the music? Is the music an improvement? Is it horrible and tacky and we should get rid of it? Thoughts? Comments? Hopes? Fears? And while you answer that, we're going to do this puzzle. So last time I did a chaos construction day. If you like chaos construction stuff, by the way, last stream I did a bunch of them because last stream was officially chaos construction day. But I had set aside one more puzzle last time than I got to do. So I'm going to do this puzzle from last time. So I was going to say, well, after last time, I'm not going to do many chaos constructions for a little bit just to let them sort of lie. But then I opened with what was basically a chaos construction puzzle. So, you know, I'm pretty easily baited by construction-y puzzles. But let's see how this one goes. Navarro, did you stream this one earlier? I know you just binged puzzles from grkles. Yes, Glum Hippo. Thank you for noticing. Alrighty, so let's read the rules because I haven't. Enjoy dinner, grkles. Or sorry, not grkles. Enjoy dinner, Directionary. There we go. Enjoy seeing me solve your puzzle, grkles, I should say. Okay. Normal Sudoku rules apply. We have to break the grid into regions. So something like... that would not be a good choice. Something like that. So we'll have sort of irregular regions, but they'll all have 9 sides. They'll all have 9. You weren't able to do 9 grkles puzzles in one stream? Imagine that. And eventually we'll have to have sort of like an official theme, I expect. But, you know, it'll be a while before we get there. I don't know why. I just wanted to draw a bit. We have a nice little pillar here that has no significance to the puzzle. I just thought it looked nice. Sort of like that one Bakpal puzzle where it's a grid that I think has a couple clues in it, but then the rules just encourage you to do whatever makes you feel good with the grid. Perhaps fill in some digits, perhaps color some squares or whatever. One of my favorite puzzles in the puzzle archive. Anyway, we'll stop the Sudoku art for now. Oh, sorry to hear that, Glum Hippo. I'll see you later. Digits marked with a circle indicate the number of distinct regions in the surrounding 3x3 square, including itself. So if I see a circle like this one, it tells me how many regions occur in the thing around it. So for example, this sees 8 regions somehow in these 9 cells, which is utterly absurd, but somehow we'll make it happen. That, in fact, actually, well, I'll get there in a second, but that says something completely ridiculous. And digits marked with a square indicate the number of cells in the surrounding 3x3 square. Sorry, not the number of cells. I should not have stopped there. That share a region with the marked digit. So the square will say, how many of the cells around are in the same who's a what's it. Alrighty, so that is the rules. So I see a couple places to start. One is a note that because of this 8, all 8 cells on this ring are all in different regions. So I could start by coloring that, because this sees 8 different regions. And the center cell has to be the same region as one of these 4. But I think these 1s are actually a more sensible place to start. Because we're saying there's only one region in all of these. And this one I can do the same deal down here. And that seems like a plus. Now, this digit I know is at least 6 because this square plainly sees at least 6 cells within this region. Likewise, that one. And that's it. That's all I know. I'm intrigued by this one. The square is equal to the circle. So the square being equal to the circle. Oh, that's a good point. Sorry, I'm gonna pause that because Changeable made a really good point, which is to look at this circle. How many regions could there be? Well, there's not one, so there are 2 or 3 regions that this could possibly see, because it can't see more than that because it's only got 2 cells that it could see. Okay. What is the most regions that this could see? You can see 1 region here, 2 regions here. I think the most regions this could see is also 3. I don't think I could possibly fit 4 regions into this area. Because all the regions that I put in here have to get out somehow. So, like, I could do that or whatever. So I think the most regions that I could possibly put over here is 3. And ergo, I think I have a 2-3 pair in this row, which means that there are either 2 or 3 cells from this region in this collection. It also means this cell is at least 4. And it definitionally can't be larger than 6. Yeah, the circled 8 I commented on to start with about how all of these things have to be in different regions. But I didn't want to pencil mark it with regions. What I can do is I can pencil mark it with the pen tool so that we remember how this works. So yeah, so this is... Yeah, but this being at least 4 isn't telling us anything. I don't know that this is at least 4. Yeah, I know this region's going to have to continue out. I know this region's going to have to continue out. Okay, so these 3 things are different regions. This one has to continue out, whatever it is. This is going to have to see at least 3 different regions. I guess that's not super helpful. Okay. Could this ever be a 2? I don't think this cell can possibly be a 2. Because if this is a 2, it's saying it sees 2 cells in its own region. And it sees 2 regions. And if you try and imagine what that would look like, well, it can't be in yellow, because if it was in yellow, then, well, it would already see 3, because it includes itself. So it's not yellow. So if this was a 2, it would be a different color. But now that color, let's say it's green, would have to take some of these cells. But now it could only ever take 2 of them. And now, in order to avoid seeing any more regions, I'd need the other cells to be yellow, and I can't possibly have all of these yellows. The circle and the square means it's both a circle and a square. So this is both the number of cells in its region that it sees and the number of regions that it sees. And I think we've just argued, to my satisfaction, that this digit has to be a 3. Now, this being a 2 is interesting. Oh, maybe it's not. Sorry, I may have overreacted with how interesting it was. It might not actually be that interesting. Because it says either yellow continues over here or it doesn't. It does say that these can't be part of 2 different regions that aren't yellow. But that's a whole who's a what's it. Ah, okay. So this 3 is actually very interesting if you look at what we know about box 5. Uh, this 3 only sees 3 different regions. Well, we know that this cell, and this cell are all in different regions already. So it can't see any more regions, which means the 8 has to belong to one of these 2 regions. Because the 8 can't be part of a new region, which means we actually can draw in some pen tool action here just around the 3. So that's nice. Now, this needing to see 3 regions, I think requires this cell and this cell. Yeah, these 2 cells have to be in different regions, and those regions have to not be yellow. Because if these 2 cells were in... if either of these cells was in the same region, if these were both green, for example, then this couldn't be a 3. And if either of these were yellow, this couldn't be a 3. So I can go ahead and do that. Now, I know the green is going to have to get out, and I know the purple is going to have to get out. I know the purple... Oops, sorry. I know the purple is going to have to get out again. So now this 3 cannot... Oh, sorry, it could be green. So this 3 actually has a lot of optionality. It can be green if green does that. It can be purple if purple does that. And it can be yellow if yellow does that and purple does that. Okay. This digit, though, is higher than 3. Because it already sees at least 2. It's going to need to see a third. So this is 4, 5, 6. Sorry, it can't even be 6, because this is counting green cells. So this cell is a 4 or a 5. Those are the only options for this cell, which is very interesting. So either all of this nonsense is green, in which case this would be a 5, or some 2 of these 3 are green. What can this be? Oh, unfortunately, this can be a 3, so that's not so exciting. Okay, where else can I make appreciable progress? Let's see. The circled 3 next to the 8 restricts where the circled 8 joins, as SPQ. I think we got that. Okay, this needs to see 4 regions. And it already does see 4 regions. So that is of note. Let's see. I'm going to use the pen tool to just note these ones that have to get out. Like that I know these are in the same region. I just don't know what that region is as of yet. Let's see. Ben makes a claim that in general, squircles have to be 2, 3, 4, or 5. Right, because if it were a number larger than 5, let's say it was a 6, that would say that 6 of the cells around it are the same color, but also that it sees 6 different regions, which is clearly contradictory. So 5 is the absolute maximum. And so I agree. That's a great spot, Ben. 2, 3, 4, 5. This one's not a 4. I think this one could unfortunately be just about anything. Let's see. It has to get out somehow. let's see. Navarios is row 2, column 6. Cannot be a 9. Right. It can't be a 9, because if it was a 9, it would automatically be a 10-cell region. So this is not a 9. Because of this this hoodigi. Oh, there's a negative constraint. Oh, yes, I had not appreciated that there was a negative constraint. I apparently gave up before finishing reading the rules, which is not a recommended strategy. But yes, so there is a... so yes, so there's a negative constraint, so that is helpful. Row 1, column 7 can't be a 6. Oh, right, because this cell now became green. So yeah, it is a 4 or a 5. Let's see. Does the circled 7 require these to be different regions? Is a noble question to ask, Josh. Let's see. So that's going to be one region for sure. If this were the second region, I could just get by if all 5 of these were different regions. So it doesn't immediately require it, but it seems very likely that what you say is correct, Josh, is my my prediction. Oh, because of the circled 4. Yeah, the circled 4 I was not appreciating. So if we went with the possibility that I mentioned, that all of these... Wait. Ah, yes, that's 5. Right. Okay, so if we went with the possibility that the 8 actually connected here, the 7 connected here, and then these were different regions to make the 7 work, that breaks the 4. So the 4 is already seeing 4 different regions. The 4 already sees 4 different regions. So every cell around the 4 is part of one of the regions already seen. And so that means that the 7, currently, if you look at it, is seeing 1, 2, 3, 4 regions. It needs to see 3 more, which means 2 things. First of all, it means that has to be in a separate region. But it also means that the 8 actually has to go up like this. Oops. Did we believe that? Okay, so now this square, it already sees 1, 2, 3, 4, 5 regions. So this can only be, I think, a 5 or a 6. Row 7, column 4. It's boxed off from the 7 too. Yeah, we... Oh, it's boxed off from the 7 as well because of that because of the argument. Oops, that's not what I was trying to do. Yeah, let's go back and look at that again. The 7 is seeing that region 1, 2, 3, 4, 5, 6, and I know that's in a region it's already seen. So if this were the same region as the 7, that would not be enough region. So these are also boxed off. That is an excellent catch by Acid Helm. Sorry, by Ben. Let's see. So could yellow possibly connect up to here? So in other words, could this be yellow? I bet we could rule that out if we looked carefully. Okay, so if this were yellow, then this cell would need to be a 5. That would be a 4. This would be a 7. Okay, that actually works quite well. Maybe this is yellow. Do I know this is part of the 4 region? No, this could be part of the 7 region. That's the point. Okay. Coloring the middle uniquely. That feels like so much to lose because we actually have all of this information. So Chad is suggesting that we do the thing I didn't do at the beginning, which is to instead color this stuff and work our way out. But I don't think I'm yet prepared to abandon this stuff because this seems very useful. Row 8, column 4. What can this be? Let's see. If this was a 2, that would be quite a thing. So if this was a 2, it would have to mean this region did that, and this region came down here. So I guess possible. Well, I agree. The regions have to make it to the middle somehow, except at most one region. Although I think people are arguing. I think people are arguing correctly that I don't think the 7 regions that this circle sees can possibly be 7 of the 8 regions that this circle sees. But yeah, the fact that the corners have to that at the very least, even without any real thought, the corners have to make it, all but one of them has to make it to the center, is quite interesting. Okay, so this digit is at least a 4. 5, 6, not 7 or 8. Sorry, 4, 5, 6, not 7 or 8. And there's no way it's 9 for lots of reasons. To row 7, column 4. Yeah, okay, that's a good point. So I think Ben has this well reasoned. This is the 9th region. So 8 of them meet the center, and then this is number 9. Because nothing from the center can possibly get here, because it would have to wrap around another region to do it. And that's not going to work. So every region is either one of the 8 that touches the center, or it's that region. Yeah, that's a good point. So, Numasaki points out that this 4 can't take 4 cells because it would be squared in addition to circled if it took 4. So it can only take some number of cells. It can only take 3, in fact, is the only, I think, number it could reasonably take. row 5, column 6 is somewhat restricted. Okay, so this sees, it already certainly sees 1, 2, 3, 4, 5 regions. So I think this is at most 7, and it's at least 5 if I counted correctly. Let's see. Carl says 2, 4 pair in row 7, column 4. And row 8, column 4. Okay, that's a good point. Okay, so what is the most cells in this region that this could see? So if this was blue, say, it could see up to I believe it could see up to 5. So I think that this is at most 5. It's not 1. So yeah, so I think this can be a 2. It just can't be a 3. And I think it could be a 4 or a 5. The 2 would be really natural if it sort of snuck over. How could this be a 4? If this sort of... it could be a 4 if blue did, say, that kind of thing. That would make this a 4. Let's see. Okay, so... and then the next question was, how many regions can this possibly see? Well, it has to see more than 1. So it has to see at least 2. It has to see more than 1, because if it didn't, this would all be blue, and that's too much blue. It can't see 3. Let's see, if this wants to see 4 different regions... I don't think I can quite count how many regions this can see. I think it could see a bunch of different numbers of regions. Let's see. So these are all the same. That's 1. These are either the same. This is at most 1 more. So that's at most 2. That's a third. I think you could see a 4th over here, but not a 5th. I can at least convince myself I don't think that this can be more than 5. Let's see. Okay. Let's go back to this, because grkles said I did not correctly count to 4. Because I was asking, how could this possibly be 4? And I guess the answer is that. If this is a 4, it could do that. And that would be fine. As long as blue sort of continued along in some direction or other. Yeah, and the square, I suppose, is an option as well. Yeah, that's true. So if this is a 5, then it has to look like this. In which case, what number is this? And that's very interesting because now this can't be a 3. Oh, but it could be, sorry, it could be a 5 and look like that. Ugh, that's annoying. So Ben is giving me a good way to visualize this. So these cells here have to each either go in the 7 region or go in blue. They can't go in some hypothetical additional region, because that region would have to go back and touch the center somehow, which would then enclose the 7 region, which it cannot do. So actually, all of these cells are either part of the 7 region or they're part of blue. So all of these cells in total are contributing 2 to this circle. The 7 region. No, that's not true, because the 7 region could let something sneak in down here. Oh yeah, and the 7 could be blue. That's a good point that I was not really properly thinking about. Yeah, the 7 could certainly be the blue and just finish like that. Sorry, I was getting myself... but I am thinking that 5 was overly optimistic. But maybe not. The counting is... there's a lot of sort of accounting of where things could go that is a little tricky and is very much tempting me to argue things in a non-rigorous way that will then get me in trouble, because it will turn out that a thing I argued is wrong. Okay, so Stephen is saying if 7 is blue, that doesn't work, because if 7 is blue, then I know that this sees 3 regions. And I believe that, because if the 7 is blue, this is a region that's not blue, and this is a region that's not blue, but that region has to get out. So yeah, so actually I do know that the 7 is not blue. So we actually can argue, okay, I believe now the 7 region is not blue. So I'm going to give it a color that is not blue, like red. So blue now... I think blue now has to take this cell. Because blue has to get to the center somewhere, and anywhere else blue tries to get to the center is going to involve it cutting off this region, because this region is now boxed between wherever blue goes. So that is blue. Now, did that reduce my number of options here? Okay, so this cell... I don't know why I haven't pen marked that. I should have pen marked that a while ago. So row 8, column 4 is a 2. I don't see why it couldn't be a... Oh, okay. Do I see... So the only way that this is bigger than 2 is if that cell, and that cell... Wait, no, it doesn't have to be that many, does it? So this could be a different region, and that could be a different region, and then it would be a 4. So I think that's fine. I think... Well, actually... No, I think if this cell is not blue or red, then I think it's going to create the same problem where now red is getting entrapped by something and is not going to be able to finish. So I think actually... I think I am being won over to the idea that this cell is a 2 or a 3, which means it's a 2 because by Sudoku it can't be a 3. Because if a different color comes down here, that color has to wrap up to one of these places around the 7 or 8. And however it does that, it's going to not leave room for the 7 to finish. I think. That sounds right, although I'm not sure that I want to prove it. Let's see. Yeah, there's just no way for something to sort of meander around here and get back while leaving room for this to finish. Although, let's see. What do I have to prove in order to really prove that I can't get a thing from here? So it would have to go... Yeah, okay, so I think I can do it. So the minimum width of a region is 3 cells. So if something started here, I'd need to go at least 4 cells right, some number of cells up, and then at least 4 cells back. And that's more than 9 cells. I think I could write a proof of this that is you see, but grkles, it's not isomorphic to it being on the edge of a grid. If it was on the edge of a grid, I agree, we know the logic, but that's not quite what's happening here because of the different shape here. But I'll just pretend I've proven it to my satisfaction, because grkles obviously believes it, and if grkles believes it, it's got to be true. But one has to be very careful, because the statement that you just can't have a region enclosing another region is not true by itself, because you can do things like in the corner, and so anything that looks like a corner... you have to be very careful about applying the logic that you can't have a region surrounding another region, because there are lots of ways for it to happen. They just involve very specific constellations. But I believe that it cannot happen here. So if these are both... I said that these are both blue or red, is the point. So this is seeing at most 3, but it can't see 3, so this is a 2. Which means that this cell's blue or red, which means this is a blue. Now it's not the same color as this, so this has to get out. Now this isn't a 2, so it's a 4 or a 5. Now this is an 8 or a 9, just from that. This is a 5 or a 6, based on that. This is not a 2 anymore. Something has to make it down here. That could be blue, I suppose. Maybe the better question, something has to make it here. This cell can't possibly be blue anymore. Because if this cell was blue, it would isolate this. So this is some non-blue color. And so whatever non-blue color it is, it has to get out. Yeah, Josh, but what that means is that if you're trying to make a proof, you have to be very careful because your proof can't cover the case where something was in the corner. So I agree with you intuitively, but I've done enough compass puzzles to not try and make claims about what regions can't do. Let's see. But I get that I try to be more precise than I think most people do when they are solving puzzles with these sorts of reasonings. Let's see. And the obvious thing would be for this to dip down and go there. I guess it could go through here as well. Oh, that SBQ has a very nice observation. If this is a 5, then that puts a blue cell here, but then that means this is also a 5. That is a sweet argument. So this is actually a 4, which means that's not blue. And by previous arrangement, that means it's red. I suppose I don't need a line through areas that I have colored. Could this be red? If this was red, it would have to be a 5. That looks hard to me. I don't know if I want to prove it, though. Okay, so if this was a 5, if this was red, it would have to be a 5 because it can't see only 3 regions. Red has to get out and can't get out without this seeing another cell, which would push it up to 5. But if red now wants to be 5, red has to get out somehow, like that or that or that or whatever. But now, actually, I think I almost believe that this is turning into a proof. Because now this would have to try and see 5 different regions. But there's no way 5 different regions are coming in down here. And no matter how I do this, I'm going to be, if I try and make this cell red, I'm going to be creating a space of cells that have to be the same color. Let's see. The absolute best is I could make this blue, make a W in red here, make this dip down here. No, this can't be 5 if it's red, and it can't be 3 if it's red, so it's not red. Okay, I believe that this is not red. Let's see. SPQ, sorry, Carl says row 6, column 4 is now a 5. Let's see. So we can just count the regions. 1, 2, 3, 4, 5. Yes, I agree. It's a 5. Just by counting. Oh, sorry. All I know is this cell's blue or red. That doesn't tell me anything. Never mind. Okay, so blue's last cell is here, here, or here. Which is not immediately useful. Now, this region, it has to be the 5. These have to go together. Because if these two don't go together, then this region is going to have to get sandwiched in between this region as this region finds its way around to the 8. And that's not going to work. So this... The blue is the only region that the 8 in the circle is not marking. That is correct. So although I don't think there's a way to... Well, I could do this. I can color this all in... I've not used orange yet. We'll make that all orange. I do not know which of these is orange. Now, could this possibly be a 2? This being a 2 seems... Oh, no. I don't think this can possibly be a 2. But I don't know if I think proving it is productive at the moment. Let's see. Row 8, column 6. What region could it be? Okay, so it has to go with the 4 for much the same reasoning. Does it tell us anything that it has to go with the 4? Like, I could make up a color for it, but I don't know if that's doing anything. Now, one thing it does do is it does tell me red has to go down here. Because the fact that these two are in the same region, they can't possibly have enough room for red to finish without taking this cell, can they? I don't think so. This is, again, one of those things where I just know I'm going to tempt myself into proving something that, yeah, even in the absolute best case, that this region gets even more cells than it's actually allowed, red still has to take this cell because of the fact that these are connected. And red has to keep going around here as well, because, again, red still needs to get a bunch of cells, and it's getting at most 3 from inside this loop. Oh, maybe not. No, this doesn't work. This is not allowed. This is too many cells. This is 10 cells. So this is the most cells I could possibly allow in here. And this doesn't work for various reasons either, because this boxes in things. But in any event, this has to be red and this has to be red. There's no getting around that. Is the point of this argument. And now, this can't possibly be a 5 because it's already seeing 5 of one region. So it can't see 5 new regions unless there's 2 regions in one of these boxes in some sort of Schrodinger region puzzle. Please do not make a Schrodinger region puzzle. So this is a 3. Which means that this sees 3 cells out of the 4 region. And it sees 3 total regions. So I think that means red can never take this cell. It does. Red can't take this cell anymore. Because if red takes this cell, now this 4 region is going to have to come down and grab this cell. But now this is never going to see a 3rd region. So this cannot be red. And so now I think we can award a color to this region for its honor in battle or whatever. We'll make that yellow. And now one of these two cells is yellow, and one of them is another color. So neither of them is red. So red has to continue over here. And so we know that this cell is either a 3 or a 4. Okay, yellow definitely has to get out, but again, a region has to get in here somewhere. If that region got here, then it would have to enclose yellow in a way that I think is not possible. So I think that region has to get here. So I think this cell has to be yellow. And this cell is not yellow. Now, this region, and again, it has to be this region that's making it down to this cell, can't enclose a whole lot of yellow in here. It can enclose at most 2 cells on its way down, maybe 3 if you're really lucky. And so that means yellow has to get out, because yellow needs more cells, which is now going to force red to get out. Up to at least, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 9. Okay, so there we go. So that is red finished, and we have our region dance. Yeah, I don't even think you had to think about what had to take row 9, column 9, because of our yellowing, I think got us that then red just had to keep going, and so I think this region's now done. And so we can count, this is a 3, which is disappointing. It would have been better if it was a 4. But now this has to be yellow. Remember, this cell's not yellow. So whatever this is, it has to get out. Now, we do know it is this region. We already said that. So we can go ahead and make another blue region, I suppose, up here. Okay, how many regions are we going to see in this cell? We're going to see yellow and red, at the very least. But then I think we see at most, well, we don't even have to argue if we can see 4 or not. We see at most 1 more. So this is a 2 or a 3, I believe. These can't all be, so if it were 5, these 3 cells would have to be from 3 different regions that aren't yellow and red, and that's definitely not going to work. So this is a 2 or a 3. Ah, that's right. Okay, so the purple now I want to demote. So yeah, purple and green are now going to get demoted. Because I don't know that they're not yellow. This is always 6, isn't it? Because wherever blue finishes, this cell's going to see it. grkles says, "Hi, Tristan," in all caps.
Hi, grkles.
So this is always 6. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9. If this cell were blue, it would immediately force... This is going to be green, by the way. If this cell were green, it would immediately force yellow to finish exactly like that. Oh, that doesn't work. Okay, got it. Okay. So this cell can't be green, because if this cell is green, now yellow, in order to finish, has to go up here, but now this is a 3, and yellow already has a 3. So this cell is not green. Yeah, the only world in which this is not... Yeah, so the only world in which this is a 3 is if it's somehow not yellow. And if this is not yellow, it's going to have a lot of work to do. Because yellow... Let's see. If this is not yellow, then yellow is going to get pushed up to at least here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this is now going to get pushed up around here. And that's not enough cells. That's only 7 cells. It didn't see the center. It's broken in 60,000 different ways. This cell can't be not yellow. So this cell is yellow, which means that this is a 2. And the fact that this is a 2 means these are also yellow. So now yellow is done. Oops. Now, if these were not green, what would happen? Well, they'd have to get to one of these cells around the 8, and they'd trap the green in a way that we have agreed, we've agreed to pretend we've proven is not possible. So these have to both be yellow. Sorry, these have to both be green. Okay. Do I know what this is yet? 1, 2, 3, 4. I think I can rule out 7, can't I? 1, 2, 3, 4. Yeah, it could be at most 6. For whatever that's worth. Now... Yeah, so now the question is, what happens in the universe where this is not green? And I think this is what Ben is saying. If this is not green, well, it could maybe grab those 2 cells, but then it's going to have to keep grabbing cells like this, and it's now cut off green, and that's not good. So this is green. And now green is done. I'm not sure if that's exactly how Ben was arguing it, but that is how we will see it. Okay, so now this is part of a region. It's got to come over here and go down here. This now can't be yellow. So this is a 3 of whatever it is, 3 of flowers. So it's going to come up here. Let's go ahead and give it a color. We'll give it purple. So we are slowly narrowing down. Okay, so again, we get to play the what if this is not purple card. Well, if this is not purple, purple has to get out this way, but then this gets crushed immediately. So that is purple. We now know this is a 4, just by counting. Same thing if this is not purple. If this is not purple, I mean, if purple's going to get out at all, purple has to get out through this little corridor. So nothing else can also get out through that corridor. So these are both also going to be purple. And purple has now made it to the centerpiece. But purple's not done yet. Now, purple can't take this stick. It's like the edge of the grid, but it's a lot easier to prove things because there's a lot less space. You don't have to consider all three things at once. I also don't know why my laptop is spinning up while I'm doing Sudoku. It usually does not even spin up when I'm doing fancier things. Maybe Steam is trying to update in the background. Is that what's happening? Steam, go away. All right. Sorry. Distraction. These have to be purple because purple can't ever take this. That would break the 8 in the middle as well as 7 other things. So these have to be purple. It's the only cells that purple can get. And purple is done. Yes, the computer is definitely thinking very hard. And the nice reward is we get to fill in a bajillion squares and circles. So this is a 2. This is a 4. That had better be a 5. This is a 7. This is a 1, 2, 3, 4, 5. This is a 5. That's not a 5 anymore. Okay. So now if this were not yellow, we'd run into this same problem again of yellow would then have to come around and cut into the center somehow and would strangle this region because it would have to get out quite a ways, and yellow only has 3 cells to finish. So actually, I did not think this was going to turn out to be yellow, but it proves me wrong. It turned out it was yellow. A little disappointing, frankly, for it to turn out to be yellow, but I'll accept it. So this is a 7. This is a 5. Let's see. What is this going? Okay, so what is left in yellow? Let me do it that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's too many digits. There is an 8 in yellow. I am looking right at it. Okay. That's not a 3. This is not a 9. Nor could it possibly in any universe be a 6. Because if this were a 6, I would need all 3 of these to be in different regions, and then I would need to discover another region. So this is a 3. And so that means all of this is in one region. Let's see. That can be another blue, I suppose. This cell also has to be blue because otherwise it would have to strangle blue as it tried to come up. And this really is the edge of the grid thing because we actually have a vertical column here now. So now we actually could reutilize our edge of the grid logic. Let's see. We have a 6-9 pair that we can't even use, which is a shame. Let's see. Let's try and mark all of our Sudoku up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is the negative constraint useful on one of these? I'm never going to see the negative constraints, am I? There's already a 2 in purple, so not 2. Let's see. These aren't 1, at least. That one's not 1 either, so that's a 1. Let's see. These would, under no circumstances, be 6, 8, or 9. So I don't have to worry about that, or I don't get to worry about that, I guess. Let's see. These digits are a 1. We've got a 2, 3. We need a 4. We've got a 5. We need a 6, 7, 8, 9. One's not 1. That one's not 4. Let's see. I just want to find one negative constraint and I'll be happy. This can't be a 4 by the negative constraint because this sees 4 cells by squares. So not a 4. It's not a 6 either because there's a 6, in fact, looking at it over there. Let's see. We've got a 169 triple down the column, so that's a 4. Let's see. If this were a 6, would it be counting the number of regions? No. Where is 2 in red? It's not in any of these places, so the 2 in red is there. So what is left in red? We need a 1. We've got a 2, 3, 4. We need a 5, 6. We've got a 7. We need an 8, 9. This is not 1 or 5. That's not 1. Disappointing. I somehow thought that that was going to do better for me than it did. Let's see. Seemingly, by the title. Two in column 8. That's a good question. 2 in column 8 goes here. Oh yeah, this 2 should have a circle. Uh-oh. Did we break the puzzle, grkles? I think we broke the puzzle. Save us! Because as Chad is pointing out, this definitely sees 2 regions, so it should be in a circle if it's a 2. Here's where grkles pulls out the solution page and has to try and figure out whether we have screwed it up somehow. I'm just going to hope that grkles missed a circle. That is my current hope. There's another spot for that too. Oh no, I'm right? Okay, grkles says I'm right. Okay, so there just is a circle here. We're just going to fill it in, and grkles had it there the whole time. So we will continue onward. Very easy to do in negative constraint puzzles. Okay. Interestingly, yes, negative constraint puzzles are a gigantic pain to check. Okay. Someone was saying, couldn't 2 have gone here? But 2 going here would have had exactly the same problem, that it would have also been counting that. So let's see. So what are these? 1, 2, 3, 4, 5, 6, 7, 8, 9 are those. That one's not a 7. That one's not a 6. Let's see. 2 could be in row 9, column 8. Yeah, Chili was pointing out that the 2 could be here, but it would have had exactly the same problem. I do not know why it did not occur to me at the time that 2 could go there, but what are you going to do? Where is 3 in green? I think 3 in green can only go in one of these 2 places. But 3 in green cannot go here because of the negative constraint. So 3 in green must go here. So that gets placed. Let's see. I have a 6, 7, 8, 9 quadruple in yellow. I do not see it. I seem to have a 6, 7. Let's see. Row 2, column 4 helps coloring. Okay. What digits could this be? Okay. So it's at least 3 by geometry. So it's 3, 4, 5, 6. Except it's not 3. It's not 4, and it's not 5, and it's not 3. So this is a 6, which, as Ambrose points out, blues this whole region. Now this needs to see 3 different regions. That's not super helpful. Never mind. This seeing 3 regions is kind of useless. Let's see. Row 7, column 6. So this is a 6, 8, 9, if I bothered to fill it in. Tom had said I had a 6, 7, 8, 9 quadruple in yellow, but I had not seen it because I had not actually filled in this cell. But that does indeed give me a quadruple, which means that these are a 1, 2, 3, 4, 5 pair, which hopefully is resolved, and it is. That's a 1, that's a 5. Let's see. Does this 1 do any significant damage? Let's see. I do need a 1 now in one of these 2 places in green, owing to that. Oh, sorry. That should be corner marked by tradition. Let's see. What is left in this column? I might as well mark it. We need a 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not an 8. That's not a 1. That wasn't super helpful. Okay. Let's see. So now people are looking at this cell and figuring out what the maximum number of regions it could possibly see are. So we've got 1, 2, 3, 4, 5 regions done. And that's a 6th region that this circle can never see. So this circle is a 2. Just because, again, this circle can't see any of the completed regions and it can't see blue. And it can't be a 3 because there's already a 3 in blue. So this is a 2. Which means that every cell in here belongs to either this region, which I'm going to go ahead and put in. I'm going to promote you to having a coloring of purple. This, by the way, is not a 2. This is a 3 or a 4. This must be blue by the negative constraint, because if this were not blue, this would see 3 cells. So that's blue. So purple has to get out. So now, what is the maximum number of regions this could see? 3 is the maximum number. Uh-oh. We broke it again. 3 is the maximum number of regions this could see. But it can't be a 3, because if it's a 3, it breaks purple. Do people agree the puzzle is broken? Do grkles agree the puzzle is broken? It can be a 3. How can it be a 3? How does purple get out? Oh, never mind. Sorry. In my brain, this somehow saw all of these. Don't mind me. Okay, so never mind. So purple only gets to see 3 things, and so that means purple has to immediately leave the surrounding area. I just can't count to 3. That's a problem. I'll work on it. So purple has to go up here, and purple can never cross any of these lines again. Now that means that these cells have to be orange, because, well, what else are they going to be? They can't be anything else. Purple, of course, has to go up. We can go ahead and do some more bordering to make it look like we're being productive. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is 2 or 3. Because it either sees purple and orange or purple and orange and blue, depending on how it's feeling today. Now, we can actually count because purple needs to take 4 more cells. So purple takes 4 more of these cells. So orange needs to take 1 more. Orange can't take fewer than 1 more. So if purple came over here, we would be in big trouble. And so orange comes here, but now purple needs to finish, and so purple takes all of those cells. And we have purple done. No, no, no. I miscounted. Oh, yes, sorry, you're right. This blue region, how about? This blue region needs to take a cell. So in fact, actually, these 5 cells are claimed by blue and purple in their entirety. So orange can't take more cells up here, if I count correctly. So 2, 3, 4, 5, 6, 7, 8. Okay, so orange takes one of these 2 cells, and I do not know which. Let's see. This 6 looks over here. Tells me that's a 9. That's a 6. So that's not a 6. These are not 9. Those being 1, 6, 8 lets me finish filling in the Sudoku for green. 1, 2, 3, 4, 5. No, not 5. 6, 7, 8, 9. These are a 4, 7, 9. That one's not a 7. That one's not a 4. So that's not a 9. These are not 9. Let's see. I do know the 3 in the row is in one of these cells for what it's worth. I think I probably need to write in these. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is not 7 or 9 or 1. These are not 1 or 4. This is not 4. Or 7. I was somewhat hoping that would be the... Chat really thinks row 2, column 1 is 2, so let's figure this out. No, row 2, column 1... Oh, sorry, row 2, column 1 they think is a 2. Okay, let's go with chat's point. So let's just fill this in. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is a 2, 4, 8. There is no universe where this is an 8. And there is no universe where this is a 4. So it's a 2, and that's a 3. Beautiful, chat. Well done. So that's a 2. Sorry, so that's not a 2. So now this being a 3 actually lets me finish my coloring, because now this has to be blue, and that's orange. Well done, chat. This can't be an 8 in any universe. So it must be a 4. That's the 8. So these are not 8. That being a 7, 9 makes that a 1. So now the question is, which thing can this be? And see 4 things. So if this cell was purple, then that would be blue, and all of these would be purple, and it would see 5 things. So it's not purple, it's blue. And so this is purple. And there we go. Alrighty, let's see. So now we've got to fill in the rest of this, I suppose. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 5, 6, 8. That one's not a 6. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there 4, 6, 8, or 9? That one's not a 4 or a 6. So it had better be an 8 or a 9. Let's see. Purple does need a 1. The purple 1 can only go here. Oh, someone says there's 1 3 left that we've not placed. That sounds accurate. The remaining 3 goes here. Let's see. These 2 cells are 1, 2, not 3, 4, 5, 6, 7, 8, 9. This isn't a 1 or a 4 or a 6. It's a 7 or a 9, which I will come back to in just a second because it gives us a 7, 9 pair, which lets us finish the column. We've got 1, 2, 3, 4, 5, 6. So this is an 8 down here. So that's a 9. I guess I could have filled in that was a 9 in retrospect as soon as I had that. But what are you going to do? So that's a 7. This is not a 7. Hey, likewise, welcome. Welcome back. Always glad to have you here. This 8 looks over and says that those aren't 8. This 9 says that that's a 1. That's a 9. Let's see. That being a 9 says that these aren't 9. Feel free to post it on CTC. If you're talking about the puzzle for my puzzle design challenge, feel free to post it on CTC. Let's see. I can finish red, I am told. Let's see. That's not a 6 anymore. But red does need an 8, so that's an 8. Oh, red has a 9. How about that? That's a 6. Yeah, if you have joined since I announced it, by the way, there is a mini... competition's not the right word, because it's not like there'll be a winner, but I am doing a puzzle setting challenge of a Sudoku puzzle with no 5s. So if you make me a Sudoku puzzle with no 5s, I will do it on stream a week from Wednesday, is the plan. There has to be a 6 in one of these 2, and it can't be that one, so it's that one. Because orange needs a 6, so that's an 8. That's a 9. This is not a 9. This is a 7-8 pair, so that's a 6. This 7-8 pair is resolved, so that's a 7. That's an 8. This is not an 8 anymore. There's a 1-6 pair, I suppose. So 1, 2, 3, 4, 5, 6, 7. 5 and 7 go in here. That's a 7. That's a 5. That 5 sees up and sees that that's an 8. That's a 9. That's a 4. So we've got the 4. Sorry, we've got the 6 and the 8. So that's a 5. Let's see. This is a 9. That's a 7. This is an 8. That's a 9. So what you do without 5s is entirely up to you. That would be that is the fun part of the challenge. 5, 6, 7. That can be an 8. This is a 1 or a 6, and it's not a 6, so it's a 1. And that's a 6, and that's a 1. So this is a 2. 4, 5, 6, 7 goes there. 1, 2, 3, 4 goes there. 1, 2, 3, 4 goes there. I don't believe that. 1, 2, 3, 4, 5, 6, 7, 8, 9 goes there. How about that? Four by 4 is an acceptable way to avoid there being any 5s. Yeah, that was a very nice puzzle. That certainly a lot of very interesting sort of figuring out the implications of all of these pieces as we piece everything together. All right, I'm going to take a very quick break. You can enjoy the jam again. Hopefully you will not get sick of the jam too quickly. And we will be back shortly with more puzzles. Alrighty, welcome back. I loudened the music a bit, at least on that scene for you, Xenetics. So I will try to do that. Okay, so next up, we have another puzzle with circles. I really like circles. The circles are by far my favorite constraint in F puzzles. I think it is also the constraint that I use most. If you look through all of my puzzles on Logic Masters Germany or whatever, so I'm sort of instantly drawn to any puzzle where there are circles floating around. So this is like a novel idea where it's like a chaos construction, but the regions are given to you in advance. It is a new breed of Sudoku that may be catching on. We'll see. So here are the rules. Each circle must have exactly X digits that are either equal to or consecutive to it. So if this were a 3, for example, it would be saying that 3 of these cells, so this is a count, and these numbers would all have to be equal to 3 or consecutive with 3. That would be what this is saying. Okay. And likewise, all of these circles do this. So a circle can never be 9, so we can start the puzzle by pencil marking the circles, 1, 2, 3, 4, 5, 6, 7, 8, and we can work through it there. So some circles can't be as high as 8, you'll notice, because, for example, this circle only sees 3 cells. So it can only be 4, 5, 6, sorry, it can only be 1, 2, 3, but actually it can't even be 3, because remember the thing that's being counted. The thing that's being counted is the number of cells that are consecutive or equal. Well, because these 3 cells are in the same box, I can't have a cell that's equal to this cell. So in fact, this can only be a 1 or a 2. Okay. Now, the first half, but not the second half of that argument applies here to this circle. This could be a 3 if these are a 1-2 pair and that's a 3. Because I could repeat the 3, this is in a different region. And then that also applies here. This can only be a 1, 2, or 3. Okay, now let's take this a step further and think about this cell. Actually, let's zero in on this cell. How big could this cell really be? So it has 8 cells that border it, yes. But how many cells are there that could be consecutive to this digit? Well, any of these could be consecutive, but at most 2 of them are. And this could be consecutive or equal. But that actually means that this cell is also at most 3. This cell, if you look at it, we again could have 2 consecutives in there, and then we could have a consecutive here for 3 and an equal here for 4. So this is at most 4. This one could have 2 consecutives and 1 equal, and 2 more consecutives. So this one I think is at most 5. It could have 2 consecutives living outside, and a repeat of the digit living outside, and then 2 consecutives inside. So this could be 6, 7. Sorry, this could not be 6, 7, or 8, but it could be 1, 2, 3, 4, or 5, I believe. Oh, the bottom left circle can't be a 3 for exactly the same reason that I said this one couldn't be a 3, which is that actually all of these are in the same region. So this one's not a 3. This is a 1 or a 2. Okay. Now, let's actually look at this frame a bit, because one of these is a 2. and whichever of these is a 2, it has to be flanked by a 1, 3. And the other will, in fact, be a 1 and will be flanked by a 2. So regardless, there's always a 2. There's always a 2 in one of these cells, which gives us a little itty-bitty X-wing on 2s. These cells can't be 2 because there has to be a 2 in one of these cells. Okay. Now, the 1, of course, the same is true of 1s. One of these cells is a 1, because if it's a 1, then it's a 1, and if it's a 2, then there has to be a 1. And so what that actually does is it actually gives us an X-wing on 1s as well, which places that this is a 3, and we get to do a little dance. And, of course, that we have a 1-2 pair here, so these could never be 1 or 2. And so what we're really saying is that one of these is a 3. Diagonals 2. Oh, yeah, sorry. Sorry, I should have been pencil marking this whole time. I should have also pencil marked these cells. Because I was not... I don't think it affected the logic, but I completely just missed this for whatever reason. So go ahead and do that. Now, this cell I want to restrict before I go ahead and place what this 3 means. Well, actually, I guess the easiest thing to do is to say, I removed 2 from row 8, column 2 incorrectly. Sorry, this gets a 2 back. I know what this digit is. Because this digit actually has to be a 3. Because this 3 needs to see 3 things. It can only see 2 of them within its box. So it needs to see a thing here, but there's a 1, 2... Oh, no, sorry. This could be a 3 or a 4. That's what I know. It can't be a 1, 2 because of the 1, 2 pair here. So it's either a 3 or a 4. Okay. This digit I need to cue off a lot of things, because at most, this sees 2 digits that are consecutive with it in those cells. And then it could maybe see a repeat of itself in a consecutive digit here. So this digit's at most 4. So it's not 5, 6, 7, or 8. It's also not a 3, because there's a 3 up there, you see. Why not 4? Oh, I see. Okay, I originally said something was not true, but it could be a 4. I fixed it. A 2 circle needs to have both a 1 and a 3 surrounding it. SPQ, because a 2 needs to see 2 digits. A 2 circle that's in a corner of its own region like this needs to see a 1 and a 3 in this collection of cells. But now I actually know this has to be a 4, because actually, where is the 3 going? One of these is a 2, and so one of these 2 cells has to be a 3, because I can't put a 3 for it to see over here. So this, in fact, is a 4. This can't be a 1. Because if this cell was a 1, it would force this to be a 2, but it being a 2 would mean it needed to see a 1. So this is not a 1. Wait, I think I broke that. Sorry, don't listen to me. No, that was right. This one, though, is a little less clear, I believe. Yeah, I do know that there is a 4, I believe likewise is pointing out in one of these cells. And a 2, actually, in one of these cells, because of our 2 X-wing. So this is not, of course, a 2 or a 4. Row 8, column 2 can definitely be a 1. Oh, dang it, I'm counting orthogonal things again. I'm somehow saying, somehow in my brain I only want to count digits that are orthogonal to this, at least half the time. And so I was like, but if this is a 1, then that can't be a 2 because, anyway. Ignore me, that was wrong. It is still true, however, to say that there has to be a 4 over here, there has to be a 2 over here, for this 3 to C, so this is not a 2, it's not a 4. Okay. What is the largest this digit can really be? It could see 2 things here. Okay, so out of these cells, it could see 3. And then it could maybe see something there. 4, 5, 6. It's certainly not bigger than 6, but I think if I counted smarter, I could get this down lower than that. But it is a little tricky for me to see immediately. Okay. This is not a 1 or a 2, because there's definitely a 1 and a 2 in this box over here. This is also somewhat restricted in how big it can be, although it can actually get fairly large by the time we're sort of at an interface of this many different places. Let's see. See, if this was a 3, what would that do? If this was a 3, it would put a 3 here and a 1, 2 here. Oh, it's not a 4 either, because there's a 4 in the box. Thank you, Kurban. Welcome, by the way, Kurban. Yeah, so if this is a 3, then I'd need to drape a 1, 2 around it, and this would be a 3. Which would put a 3 here, actually, for whatever that matters. Oh, no, that doesn't work. That doesn't work. Okay, this is gorgeous. This can't be a 3, because if this is a 3, I need to drop a 1, 2 around here. But that gives me an X-wing on 1s and 2s, which would put both 1 and 2 into this cell. And I cannot put both 1 and 2 into this cell. So this is not a 3. Oh, no, sorry. Why? Somehow, I don't know why counting consecutives is so difficult for me, but I didn't do it right. It would need both a... Sadly, sadly, 1 is not as consecutive with 3 as it would ideally be. So this would be a 2-4 if that were a 3. This would be a 2-4 with that being a 3. Is that a problem? I don't think that's actually a problem. I think if this is a 3 and that was a 2-4 with a 3 there, I think that's fine. This would be a 2. That would be a 3. Never mind. I think it can be a 3. Well, it was a cool argument that just as it happened was not true. Well, now I'm sad because I was excited about that, but oh well. Let's see. If this was a 4, I would need to have 3 and 5. Let's, for once, get this right. I need to have 3 and 5 there. I would need to have 4 here and a 3 or 5 there, or I guess I could have a 3-5 pair there. Oh, hey, Furby Fubar. We have the creator of Squirtle here, right? If I recall correctly, which is awesome. Squirtle keeps improving, too. Let's see. Kurobon says this must be a 3. Let's see. If this was a 2... Yeah, I did when I was originally Googling Squirtle. I did have a very hard time finding things that weren't pictures of Squirtle. So let's see. So Kurobon is pointing out something that I had noticed but had not chased far enough, which is that this L shape is like a boomerang where if I make this a 1, it knocks 1 out of all of these cells because I have to put a 1 in here, which would go in one of these places. And so if this is a 1, it makes that a 1. Which then makes that a 2, which makes that a 1. So Kurobon has noticed completely correctly that there's some sort of weird, complicated Y-wing thing going on here, where if this is a 1, the whole puzzle breaks. Because if this is a 1, it makes that a 1 through ordinary Sudoku. But then if this is a 1, it puts a 1 in one of these cells through less ordinary Sudoku, and that breaks. So this cannot be a 1. And I'm going to guess exactly the same thing happens with 2s, because I don't think there's any difference between 1s and 2s. So if this is a 2 now, then I put a 2 over here, and so this becomes a 1. But also this becomes a 1. And so in fact, this is a 3. And so these two cells are 2 or a 2-4 pair, and this cell is a 2-3 or 4. But it's not a 2 or 4 because it sees both a 2 and a 4. So that's a 3. And so now it already sees its requisite cells, and so we learn that, for example, none of these cells are 2 or 4. And some of them aren't 3 either. So that is nice. And so now I do have this X-Wing on 2s, which is placing a 2 right in this cell, much like I was hoping for to find previously. There is a 3 over down here. So if there is going to be a 3 touching this cell, that would be that. Oh, Kurobon is singing the Simon song of "That's 3 in a Corner," which is gorgeous. This is not a 3. Let's see. Oh, I totally missed that all possible circles are given. I'm not reading rules well today. In fact, I think literally the line I missed from both rule sets was all possible circles are given. Yeah, so now we know where 3 goes up here. Namely, 3 goes here, as I had noted before, and then did not apply. And now that tells us this can't be a 2 anymore, because if this was a 2, it would need a 3. So this is a 1, and that's a 2. I did that right? I correctly used numbers that were adjacent to 2, I hope. So there is a 2 in one of these cells. Because 2 is consecutive with 1. And so these are not, well, of course they're not 2. Now, if this was, okay, so this is the point on the negative constraint. If this was a 1, it sees exactly 1 digit consecutive with it, which means it should have a circle. So this can't be the 1 that this 2 sees. This is the 1 that this 2 sees. And now the 3 that this 2 sees needs to go there. For many reasons, including that 3 and these 3s and various other political problems. Now, where's the 3 going in column 3? It has to go here, right? I don't think there's any way that 3 goes anywhere else in column 3. Now this 2 bounces. Anytime you have one of these L-shaped regions in one of these funky, like, chaos construction with given region puzzles, you should make sure that you pay attention to the way the L is doing, because any digit that sees part of the L sort of bounces into seeing something in a different part of the grid. So that 2 now looks up here and sees that that's a 4, and that's a 2. That 2 looks over here and sees that that's not a 2, so that's a 2. Let's see. Now, this 1 can't see another 2, so that cell can't be a 2, is I guess all that tells me. This 2 actually, yeah, I guess it tells me there can't be a 3 in one of those cells, but that's not helpful. Yeah, this digit has to be large. I probably should attempt to figure out exactly how large, but my previous attempts at counting in this puzzle have been poor. So I am less than optimistic. Okay, so the 3 in the top hat has to go in one of these 2 places, just by looking at Sudoku stuff. Let's see. Yeah, the 3 in... where is the 3 in row 5? It sneakily can only go here, so that's a 3. So that's not a 3, and that's not a 3 while we're at it. That's not a 3 either. So our 3s are down to 2 little itty-bitty X-Wings. Let's see. Okay, so we're told not 8. So it is impossible that... yeah, if this were an 8, I would need to put a 7-9 pair here, an 8 here. But 3 is not next to 8. So because that's a 3, this can't be an 8 anymore. Okay. So if this were a 7, then I would need all but the 3. To be consecutive or equal to 7. So if this were a 7, I think that's not going to work either. So I need this to be a 6-8 pair, that to be a 7. I'd need this to be a 6-7-8. And the 7 would have to go here. This would be a 6 and an 8. And then I would need this to be a 6 or an 8. That sounds annoyingly possible. How about the lower hanging fruit? This cell is not a 3. Let's see. Need a 5 in row 3. Also not an 8. Also not an 8. What's also not an 8? Hey, Donatello. This is not a 2, because there's a 2 looking up from there. This is also not an 8 for the same reason. Sorry, I now know what we're talking about. This is not an 8 because this is not counted by whatever this is. Because the 3, if this were an 8, it sees a 3. That's not going to work. In fact, if this is a 7, it's not going to work, because it's going to see at most 2 out of all of these cells. 3, 4, 5, 6. Even in the most optimistic case, this is not a 7. Let's see. Row 2, column 7 must be the 1, right? Yeah, where does 1 go in this this universe? Well, 1 is certainly not going there. 1 in this region is going in one of these places. Oh, actually, this has to be the 1, right? Because this 2 is almost correct. So the circles count the number of digits that this digit sees in the adjacent 8 cells that are either consecutive with it or equal to it. So this 3 is reporting that it sees 2, 4, and 3. That is 3 total digits that are either equal to 3 or consecutive with 3. But all circles are given. So because this 2 cannot be correct, it needs to see an extra thing that it should be counting, which means this has to be a 1. That was a good spot, Kuraban. So that is not a 1. Okay, and so the 1 is fine. Now this 2 needs to see something else to make sure that it's not correct, because it's seeing this 1. No problem, Donatello. Happy to have you here. Are you new to the stream? Let's see. This 4 does indeed see a 3. Oh. I don't think this can be a 4 anymore. Because if this was to be a 4, I would need to have a 3 and a 5 around it in here. And then I would need to have 2 of 3, 4, 5 here. But I can't have 2 of 3, 4, 5 because there's a 3, 4 up here. So this is not a 4, it's a 1. So that 3, 4 actually did us a lot of work in terms of how that was going to work. So this number continues to be huge. Let's see. Sam thinks that this is a 5. Is this being 6 a bridge too far? Okay, so if this is 6, it again is going to see at most 3 things in these 5 cells. So that we're at 3 now. We'd need to see 3 things here. But the problem is this 3 is forcing me to put at least 1, 2, or 4 into these 2 cells. Because I need to put 2 2s and 4s in these cells. But neither 2 nor 4 would be counted by the 6. So this can't be 6. It can only be 5. Okay, unfortunately now once it is 5, that introduces a whole new layer of flexibility, because both I need to see fewer things, and the 5 does see the 4. So if I put the 4 there, then that is suddenly fine. Let's see. Is this being 6 acceptable? It could see 2 in there. Would need to see 2 there. So it would need to see 2 here and 2 here. So yeah, this would be a 7 and a 6 or something. I think that nominally... Oh, awesome, Donatello. Well, glad you're getting into this stuff. I think it's a lot of fun. Well, I'm glad to see you're engaging in the 5 list challenge. 1 5 at a time. We can rid the world of 5s. Let's see. Only 1 square for the 2. Let's see. Okay. There's some irregular logic going on, I am being told. I do know one of these 2 cells is a 4, speaking of irregular logic, because the 4 is definitely in one of these cells, so it rules it out of there. So one of these is a 4. Oops. I haven't put a 1 yet in this whole razzmatazz, so there's got to be a 1 in one of these 2 cells. If I put a 1 here, do I immediately break it because of this 2? I think if I put a 1 here, I have to also put a 1 here to make this 2 not broken, because I'm out of 3s to put near this 2. So if this 2 sees a second 1, it needs to see a third 1. Uh-oh. Kurabon thinks I broke it. Also have the option of row 3, column 9. Ah, okay, got it. So yeah, there's actually 3. Okay, got it. Yes. Okay. So sadly, we would have gotten a free 1 over here had that been correct, except that I missed that this cell can still be a 1. So actually, those are 1s. Good catch, Kurabon. Thank you. Yeah, I also got into Sudoku during the pandemic. It sort of is what kept me sane as my way of sort of making it through all of this stuff. Let's see, because I used to play tons of board games with friends and whatnot, and then of course during the whole pandemic thing, that became less possible. So it was a natural sort of fit. Okay, so interesting point. If this becomes a 5, then it can only see one of these 2. See, this can't be a 5. Okay, let's see. Is this being a 5 broken? Because if this is a 5, oh, but this could be a 4? No, it can't. Okay, if this is a 5, we see at max 1 digit out of all of those. We see 4 and 6 are the digits that are next to it. So yeah, I don't think I can quite rule it out. Yeah, I haven't gotten back to the whole board game thing nearly as much as I would like either. So this 1 is going to be interesting because it kind of wants to see one of these 2 2s, but then it also wants to see the 2 in this box, and it can only see one of them. It can't see both. It is Zeta. It's a Casey. Hey, Casey. How are you doing today? I haven't seen you around in a bit. I have seen you around the CTC server. I'm doing pretty well. Yeah, board gaming is one of those things where it's very easy to not do. So it is very easy to sort of like fall out of the habit, and then you have to like get people into the habit of doing it, and then actually do it, and then it makes life tricky. There has to be a 2 in row 8, column 9. I don't see why. So I think the reasoning has to do with fearing that we would put 2 2s around this 1. Do we know that there's not a 2 in one of these cells or something like that? Like, if I knew there was not a 2 in one of these 2 cells, I would 100% agree with you. If 2 is in that one place, what happens to column 9? Can we be more specific than that one place? Okay, so if the 2 is in either of the other places... Oh, got it. Sorry. There's a 2 up here. Hello, 2. Okay, got it. So, I can now explain this. I had completely missed this. Okay, so the 2 in this column is in one of these 3 cells. So that cell's not a 2. The 2 in this column is literally here. So that cell's not a 2. So the 2 in this box is in one of these cells. Yeah, boy, I don't know how long it would have taken me to see that this 2 was literally here. You'd think it was given or something. So this 1 already sees a 2. It cannot see an extra 2. So those can't be 2, and ergo that's a 2. Thank you, chat. Thank you. I was like going all around in circles trying to chase the 2 all over the place. Let's see. Okay, so there is a 2 amongst this mess, which is very interesting because it says the 2 that's in this cluster sees a 1 and a 3. So the 2 that's in this cluster actually needs to see another digit because it sees definitely 2 things already. And the 2 is not here because there's already a 2. Man, those 2s are practically invisible today. Let's see. Okay, so so interesting. Is there a place where the 2 can't see more things? So the 2 here would have to see a 2 there. Yeah, I distrust the invisible 2s. Let's see. Well, I do need a 1 in column 9, and I do need a 1 in row 9. And I only get 1 1 from this L-shaped cage, which is interesting. So the 1 in row 9, sorry, the 1 in column 9 is in one of these places. The 1 in row 9 is definitely, though, in one of... So the upshot is this cell can't actually be a 1, because if this cell were a 1, it would become impossible to put a 1 in row 9. Because the 1 in row 9 is definitely either here, here, or here, or here. It's in one of those places. And so that means that can't actually ever be a 1. Why that matters, I'm not sure. Let's see. Okay, Furby wants me to check for 1s in column 6. Not there. Could be there, or here, or here. I think it can be any of those places. Here's an interesting point. There does have to be a 1 amongst these cells. is that going to do damage to the 2? So if I put the 2 here, maybe not. I keep looking at places where I'm pushing a bunch of digits that are going to count each other next to each other to try and use the negative constraint, and it keeps not quite working. Let's see. It's not in row 3, column 3. If this is a 1, now this 2 sees 2 things, and it can't possibly see another thing here, so the 2 is broken. So the 1 is not, in fact, there. So what about here? Can the 1 be here? Because if the 1 is here, if there's a 1 here in row 3, then this 2 sees those 2 1s. What else is it going to see to break the spell? I guess it can't see a 2 down here, but it could see a 1 in exactly that cell. So strangely, if this is a 1, that's a 1. Oh, weird. Okay. So if this is a 1, this 2 needs to see something else. The only thing it can see is a 1, because the 3s are done. And so it needs to see the 1 exactly there. So if this is a 1, that's a 1. Otherwise, if you look at row 3, the only other place for a 1 is here. In both of those cases, this cell is never a 1. So we can rule a 1 out of there, which I suspect was totally not intended. But what are we going to do? And as pointed out, that would actually... So Furby Far says something brilliant, which is that if I put a 1 here, then I'm forced to put a 1 here, but now I can't put a 1 in the top hat anymore. So I actually can't put the 1 there at all. So I did not have to make the somewhat gratuitous chain to eliminate the 1 from there. So, right, beautiful. So that's a 1. Okay, so Sam said something about 1s. If 1 is in row 7, 9, column 9, I apologize, Sam, that your comment has been obviated by Furby Fubar. Sorry, I am really bad at... I'll get there eventually, maybe, possibly. Furby Fubar. There we go. Okay. So. Yeah, this one is seeing that too. That's fine. This 2 needs to not end up seeing 2 things. Let's see. There's now a 1, 2, 4 triple in the box. Let's see if I can figure out which box. Yes, beautiful, beautiful. Okay, yes. Excellent point. So through sheer force of will, we have pushed 1, 2, and 4 into these 3 cells in this box, which means we can upgrade them from being corner marks to center marks. And center marks are better than corner marks, if you did not know. So these are 1, 2, 4, which means that I can go ahead and pencil mark these in. These are 6, 7, 8, 9. Which I'm sure does something. Let's see. Yeah, there's a hidden 1, 2 pair in this column. In column 3, where am I putting 1 and 2? Well, not there, and not any of these places, because there's already a 1, 2 in the box. So this is actually a 1, 2 pair, which makes this a 4, bizarrely enough. So... Did I do something involving a really complicated way when I could have done it in a more simple way? Like the fact that there was a 1 and a 2 looking at this, so ergo this had to be a 4 if it had to be one of 1, 2, and 4. That probably would have been a smarter way to do it. So now I had corner marked 4s in these two places. 4's not there anymore, so now 4 is here. So now 4 in the top hat region. In fact, now the top hat region has been upgraded to an honest quadruple. Something make an honest quadruple out of you or something. I think that's the romance movie line, right? Let's see. Okay. So wherever the 1 goes, it's going to see a 2. And so wherever the 1 goes, it's going to have to actually somehow see an extra 2. Or an extra 1, I suppose. But the 1's never seeing an extra 1, because there's not a place for me to put an extra 1. So because the 1 in this cluster sees a 2, it needs to see, in fact, 2 2s. So it needs to go here and see a 2 there, or go here and see a 2 here. Is one of those obviously broken? A 1 here with a 2 here would work really nicely, I think. A 1 here with a 2 here. That doesn't look good. So a 1 here with a 2 here. The 2 would see a 1 and a 3. But now the 2 could not see another 3. So this would have to be the 4. Oh, and that doesn't work because I've already used the 4 over here. So this can't be the 1. This has to be the 1. So, yeah. So I think chat is agreeing with me that this is not a 1. Because if this is a 1, it needs an extra 2. It has to get it here. Now this 2 already sees 2 things, but now this cell has become a 3, and it does see an extra thing. So this is not a 1. This is a 1, and that's a 2. Let's see. AFrayedKnot says there's also the fact that the 2 would see row 5, column 3. Ah, yeah, good point. Good point. The 2, in fact, would already see both of these cells. So yeah, so this cell is very much not a 2. In fact, that cell's not a 2 either. In fact, that's a 3-4 pair, so this cell's a 6. So that's not a 6. And this is a 2. And so this 6 needs to see 6 cells. Did I screw something up? Because that doesn't look good to me. What went wrong? So this being a 2 makes this a 3-4 pair, which makes this a 6. What's wrong? 1 doesn't need to see... 1 doesn't need to see 2 diagonally. 1 just needs to see the 2. Okay, this is the 1, but the point is the 2 is in one of these 2 cells. Got it. Okay. Thank you. Yes, I was missing that the 1 could see the 2 here instead. Was that an option over here too? Did I screw this up, or did I not appreciate this fully? If this was a 1 and that was the 2, yeah, maybe I screwed this up before. Okay, so I think when I argued before that this couldn't be the 1, I think I failed to consider the possibility that this was a 1 and this was a 2. So why doesn't that work? If this is a 2, it now sees the 1 and the 3, and now it can't see anything else because everything else is gone, right? No, it could still see a 3 here. Okay, I don't think I argued this correctly previously. But anyway, I believe Sam's point that this can't possibly be a 6 anymore, because if this was a 6, it could not ever see that cell, that cell, that cell, or that cell. And so if that's a 6, it sees at most 4 cells, which does not sound good. So that's a 2, 3, 4 triple. We'll go ahead and fill in the 6, 7, 8, 9 across the way. This 5 sees that cell. It could see 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 that cell. So this 5 needs to see 5 of these 6 cells that it could possibly see. Let's see. Could this be a 4, 5, 6 triple? Or could this be a 4, 5, 6 triple? If I could disprove that either of these is a 4, 5, 6 triple, it would be huge. But I don't think I can yet. Let's see. Yeah, I think we indirectly proved that this can't be a 2 by accidentally bifurcating on what happens if this is a 2. Because if this is a 2, this becomes a 3, 4 pair. This 2 sees those 2 digits. And sees at least one of these digits. Okay, yeah. If a 2 here definitely sees those 2 cells and sees at least one of these 2 digits, because 4 is the only of these digits it does not see. So this is not a 2, it is a 4. So that's a 3, that's a 2. I feel like I have somewhat, whatever the Britishism is, made a meal of this puzzle. Is that the Britishism that Simon uses? This has not been my best work. Let's see. Okay. So whichever of these is a 1 does need to see another 2. Or another 1. And so what that means is, since I can't possibly see a dog's breakfast, there we go, or a ricket. A ricket Simon has used a lot too. Yeah, since it can no longer see a 2 up here, what we've learned is, and I'm not going to pencil mark this because I know how disastrously this would go, one of these 2 cells is a 2. And it goes with the 1. So there's either a 2 here and a 1 here, or a 2 here and a 1 here. This being a 4 is interesting, though, because 4 is big. So this being a 4 means it needs to see 4 cells. Okay, so it can never see this one. It's not seeing that one. Okay. I think I did not really think about how to count this 5 correctly. I mean, I have at various points, but I have not currently. This 5 sees at most 3 digits out of this L, because the only digits the 5 can see are 4, 5, and 6. So it sees at most 3, which means it still needs to see 2. It never sees this 1, 2, so it needs to see this cell, which means this cell has to be a 6. Chat got me there slowly. I did not do the best with that. Okay, so we also know we need to put a 5 and a 6 inside these cells. So there needs to be a 5 and a 6 amongst those cells. That one's not a 6 for sure. So there is a 6 amongst these cells, so that's not a 6. I feel like I'm saying amongst a lot today relative to my normal day, and I feel like I'm not good at saying that word, so I should find a better word. Let's see. Okay, so that is a big improvement. Yeah, so the 4 circle sees the 3, sees at so sees at most one of these 2 cells. So the 4 is seeing 1, 2 already. It's going to see at least one of these. Sorry, it can see up to one of these. It can never see this cell, strangely enough. This cell is invisible to the 4, because this cell can never be a 3, 4, or 5. This cell is just not a 3, 4, or 5. And so, actually, the 4, if you look really closely, the 4 can see one cell here. It sees 2 cells over there. That's 3. It needs to see this cell, or it's just not going to work. So that's the 4, that's the 1, that's the 2. And the 4, in particular, has to see the 5 in the box. So this becomes a 5, 6 pair. And that becomes a 7, which is terrifying. Although I guess it's good I didn't prove earlier that it couldn't be a 7. Okay, so let's go ahead and do Sudoku on this before we dive too deeply into that 7, because experience suggests I'm not going to do well at considering the 7. Let's see, we've got 1, 2, we've got 3, 4, 5, 6, 7, 8, 9 to place. Okay. The 2 is not going to go any of those places. The 7's not going to go there. This is not going to be a 1 or a 2. It's going to be a 7, 8, or 9. Let's see. Yeah, we've just got triples everywhere. This is not a 1 either. Okay, so this is a 7, 8, or 9. Okay. If this was a 1, this would have to be a 2. Actually, this always has to be a 2. Because this 1, wherever this 1 lives, it's seeing a 2, it needs to see another 2. And so the only place that other 2 can live is here. So this is a 2. I think that's the logic I've been trying to make work the whole time. So therefore that's a 1 and that's a 2. That's not a 1 anymore. So therefore that's a 1. Oh, it could see a 1. So actually what I know is just this cell is a 1 or a 2. Sorry. Thank you for catching me. Thank you for catching me, Josh. This does have to be a 1 or a 2. But it does not have to be a 2. It could be a 1. So this is not a 1. Which now means that we have a 7, 8, 9 triple in this region, which now means that's a 1, that's a 2, that's a 1, that's a 2. We got it the honest way that time. So now let's write in the options for this this column. We've got a 1. Sorry, we need a 1. We've got a 2, 3, 4, 5, 6, 7. We need an 8 and a 9. Well, that one's not a 1. That one's not a 1, so that's a 1. Let's see. Okay, so the 7 actually needs to see everything except for this 3. So I guess the 7's actually pretty useful. So the 7's actually not as complicated as I was originally afraid it would be. 5 or 9. Okay, because the 7 only sees 6, 7, 8, 9. So actually, actually, these need to be 6, 7, 8. These need to be 6, 7, 8. And the only way it works is that away. I think I did that right. Someone in chat will tell me if I did that wrong somehow. Which is eminently possible. 6, 7, 8 over there. 7, 8 over there. That gives us a 5, 9 pair, which means that's a 4, which I suspect is what Donatello was telling me about placing a 4. Okay, this is not a 6 or an 8. So it's a 5, 9. Last one could have been a 6. Oh, no. Okay, let's go back and do this again carefully. Sorry, Ben retracts. We will fast forward back to where we were. Okay. So not 6 or 8. So this is a 5 or a 9. To go with that, 5, 9. This digit I probably know. 2, 3, 4, 5, 6, 7, 8, 9 is what that is. Let's see. There's a 5, 6 pair. That's a 9. That's a 9. So that's a 7. Let's see. Okay, that's an 8. We may be wrapping up at this point, depending on how it goes from here. But this may have. Oh, not a 4. 5, 6, 7, 8, 9. Wait. These squares I get have to be 5. I don't think I did that right. 1, 2, 3, 4, 5, 6. We don't have a 7 in this region. That's a 5. That's a 7. Uh-oh. Uh-oh. We broke it. Let's go back to where I was doing this part. Let's see if we can do this better or this time. So none of these are 9. That's not a 9. These aren't 9. This is a 6, 7, or 8. This is not a 5. So let's see. This is in a bucket with a 7. Well, sadly, now I've entered stuff, so I can't go forward. So we'll have to bear with checking this again. 8, 6. That'd better be an 8. That'll be a 7. That'll be a 9. But it should not take long to get back there. Oops. Let's see. That's a 9 and a 1. Okay. Donatello meant the 4 in row 4, column 8. Let's see. This has to be a 4. Yep. This has to be a 4 because it's the only place for a 4 in the region. Let's take Donatello's 4. These aren't 6 or 7 or 8. They're a 5, 9 pair, so I should know what digit this is. 1, 2, 3. This has got to be a 4. These are not 7 or 8, so it's a 5 or 9. This is not 7 or 8 or 6, so it's a 5 or a 9. Okay. Let's look at this column instead, so we do not make the same mistake as last time. Let's see. We need a 3 and a 5. So that's got to be the 5, and that's the 3. These 3 digits in this region, / row, I guess, 2, 3, 4, 5, 6, 7, 8, is what they are. That was not immediately useful. Let's go ahead and update these. These are not 7, 8, or 9. That's useful. So because those aren't 7, 8, or 9, these are 7, 8, and 9 to finish this region. These aren't 9, so that's a 7, 8 pair, so this is a 9. So that's a 5, and that's a 9, and that's a 5, and that's a 9. So let's see. So now I have a 6, 7, 8 triple in this column. 1, 2, 3, 4, 5 goes here. So that fixes that that's a 6 and that's a 5. This is just really nice setting, by the way. Despite my my somehow having trouble counting to 3 in no way is an indictment of this puzzle, which I have found to be very delightful. 1, 2, 3, 4, 5, 6, 7, 8, 9 goes there. Let's see. We need a 7 or an 8. So that's an 8 and that's a 7. These aren't 7. Hopefully I did better this time at the regioning. Let's see. I know that these are an 8-9 pair because I have an 8-9 pair looking over here. So these are an 8-9 pair, which is somehow unresolved. I would have thought it would be resolved by now, but apparently not. So let's go ahead and finish this row. 4, 5, 6, 7. This is not 4 or 5. This is not 4. This is not 4. So this is 4. That is what I have learned from that process. There's also a 9 in this column, so that's not a 9, which gives me a 7-8 pair, which gives me a 6 and a 5 and a 6. That will strip out those 6s. Let's see. Donatello says 4 in column 7. Oh, I think I just placed the 4 in column 7. And then we're done with 4s. We appear to be done with 4s. Excellent. Let's see. There's a 7-8 pair here. Looking over to see that that's a 6 and that's an 8. These cells are known. If I look at the row, 2, 3, 4, 5, 6, 7 is what they are. And I know the order thanks to that 6. So that's a 7, that's a 6. And so because there's a 7 in the region, that's now an 8. So that's a 9 and that's an 8. That 7 is looking down and seeing that that's an 8 and that's a 7, which tells me that's a 6. That's an 8. That's a 7. These aren't 6 anymore. And that 7 looks down and says that that's a 5 and that's a 7. Let's see. 1, 2, 3, 4. That's a 5. And 3, 4, 5, 6, 7, 8, 9. Very nice puzzle. Very clever all around. Yeah, I'm really impressed that this digit can be as high as a 7. Just from the way that this is written down. And of course, this is why it has to be an irregular. Because if these were sort of the normal regions, then it could not be anywhere near that high, right? I'm just imagining. If I had a normal region here, then even a number that was here could be... I guess it could still theoretically maybe be. But certainly it makes it a lot easier when you have this... and they could only be high if they were on corners. See. Yeah, as AFrayedKnot says, if you want this to be unique, you have to get as high as 7, because otherwise you have no way of disentangling 8s and 9s. Which is there's a thing that often comes up in puzzles where you're trying to do these kinds of counting things, is that if you want to actually make it unique without any given digits, you need your counting thing to somehow interact with 8 of the 9 digits. If you look at Keep Talking and No One Explodes, you'll see there was some work to be done to make it so that you could actually disambiguate everything in that puzzle. Let's see. Debating if I have time for one more quick puzzle or not. And debating whether any of the puzzles I have open are quick. well, let's try this puzzle to wrap up, and then on my end you have time. Okay, so let's try this puzzle by JC Godart to wrap up. So bye, AFrayedKnot, but thanks for stopping by. Glad I got to do your puzzle, and glad you got to be here. It's always the most fun to do puzzles when the setter happens to show up. Yeah, so the title here is a reference to an old movie, for those of you who do not know. So let's see. So here, what are our rules? We have normal Sudoku rules, and we have anti-knight. So as soon as this cell's a 2, it's saying not only can the normal cells that can't be a 2 not be a 2, which would be... So normally in Sudoku, as soon as this cell's a 2, you learn these cells aren't a 2. But you also, in anti-knight, learn these cells are not a 2. So you actually get sort of a wider range of interference around numbers repeating. So these digits are in a ratio of 1 to 2. So, for example, that could be a 3 and that could be a 6. These are usually called black kropki. Numbers separated by white dots are consecutive. So these could be 6 and 7, for example. Uh-oh, Sam says he tried this puzzle and did not get it. That does not bode well for me picking a quick puzzle to wrap up with. Numbers separated by dots are also values to column indexes within the row. So this is a broken 159-ish sort of thing, where if, for example, this digit is, let's say, a 7, then what that's saying is that if I count over, this is the third column. And so because this is the third column, I would be indexing the location of the third of the digit 3, which would be to say I'm placing it in the 7th position. So that would be a 3. That would be what this is saying. Not all dots are given, and not all indexing cells are given. So you might be used to a lot of these puzzles are set up as broken 159s where they'll give you a negative constraint on indexing. This puzzle does not have a negative constraint on indexing. So all we know is these are all indexing. And so the pink is just redundant. Every cell that has a dot on it is pink. Every pink cell has a dot on it. But they're just to remind you that these do the 159 thing. Okay, and so we get to start with the fact that anytime you're so fortunate as to have 3 cells on black dots that all see each other, that tells you that there's always a 2, 4 on them, and there's always a 2 and a 4 in the middle. And that's because there's only 2 flavors of black dot, ultimately. There's the power of 2 flavor, which is either 1, 2, 2, 4, or 4, 8, or there's the multiple of 3 flavor, which is just 3, 6. But because there isn't enough flexibility in the 3, 6 flavor, we get to put a 2, 4 here to start. Right. Now, this 2, 4 in the middle is indexing the location of the 8 in the row. So the 8 in the row is either here or here. This is saying. So I'm going to pencil mark these across boxes and just try and deal with it. There is an 8 in one of these cells. Now, this cell is indexing the location of the 9. So I'm going to go ahead and actually fill in the candidates here just so I can explain this. The only things that could be here are a 1, 2, 4, or 8. Now, what if this were also a 2 or 4? Well, if this were also a 2 or 4, then that would put an 8-9 pair in these 2 cells. But if you look closely, an 8-9 pair in those 2 cells is horribly broken because the 9 can only go on a white dot next to an 8. So this is not a 2 or 4. And if this were an 8, it would be saying this cell's a 9, which is nonsense. So that's a 1, 2, 4 to start. And so now this 1 has indexed a 9 there, and the 2 is indexed an 8 there. The 4 has indexed an 8 here. And And so this cell is now a 7 or a 9. And so we're putting a 5 in one of those two cells. Okay. Does this make sense to people so far? Are people vibing with the dots and the indexing and the such? I should also remember there's an anti-knight constraint, because inevitably what happens when there's an anti-knight puzzle is that I start the puzzle, and of course the anti-knight can't do anything at the very beginning of the puzzle. And then I've completely forgotten by the time it's actually useful that the puzzle actually has an anti-knight constraint. So I should probably be using that because I don't have a whole lot of clues in the bottom 4 rows of the grid. And by I don't have a whole lot of clues in the bottom 4 rows of the grid, I mean I have literally no clues in the bottom 4 rows of the grid. Okay. So, what do I do with my... Yes, Ambrose, that is exactly what happens to me every time. Which should really be suspicious to me because I should realize as soon as there's absolutely nothing in the bottom 3 rows. It has to be anti-knight because there's no other way to disambiguate this. If there's no information, because otherwise you could just swap the... Oh, it's anti-consecutive knight? I should read the rules. This is what happens when I am dyslexic, and so reading things, I tend to just do a lot of it by context, especially when it's very small on my screen. So where is this rule? Cells a chess knight's move apart cannot contain consecutive numbers. I see. So it is not actually saying, yes, today's theme has been not reading the rules. So yes, as Jessica points out, this is especially good because I already have 2 8s that are a knight's move apart. So that is very good that the only digits I have placed are a knight's move apart and are the same digit, and that does not break the rules somehow. Yes, okay, so... What I'm actually saying is because these are 8s, I can't put 7s or 9s in the knight cells. Sorry about that. Okay, so... not going to learn lessons. That is not not an option, unfortunately. Okay, so does this do something somehow, somewhere? I mean, presumably it does. So let's see. So trying to decide how I want to break into these Kropke. So I am noticing that in this row, there is a pink cell in the 3rd cell and a pink cell in the 6th cell. So this cell, for example, cannot be a 6, because if this were a 6, it would put a 3 here and a 6 here. So that's a problem. So I actually want to write out what are all the possible digits that this can be, and I apologize. So this cannot be a 6. Could this be a 3? So if this were a 3, this would be a 6. And that is broken for the same reason. If this were a 6, then that would be a 3, and that would be a 6. It does not work. So this is not a 3 either. So in fact, these are from 1, 2, 4, 8. And so that works out. Okay, so now, if I know those are from 1, 2, 4, 8... Look at the black dot in row 3. Both sides see either a 2 or a 4. Oh, yes, okay. So Panthera with a beautiful, beautiful spot. This can't be a 3-6 dot because 3, spoiler, is consecutive with both 2 and 4. So this can't be a 3 because it sees a 2 by knight's move, and consecutive digits can't see each other by knight's move in this puzzle. This can't be a 3 because it sees a 4, and 3 and 4 are consecutive. So this is also 1, 2, 4, 8. Okay. Now, if I look at what this dot is actually doing, which is to say it is indexing the location of the 3, this can't be a 1-2 pair because that would put 3s in these two cells or these two cells, but they're both in the same box, so that's not going to work. So can't do that. So we can rule out those being ones. That was legitimate businessmen's point out. I still love the screen name legitimate businessman. So there's definitely a 4 on here for whatever that's worth. So because there's a 4 on here, that can't be a 5. Actually, this can't be, because there's a 4 on here, this cell can't be a 3. So now if I look back over to this, the question is, can this possibly also be from 1, 2, 4, 8? So this cannot be a 3. So the question is, could this be a 6? If this were a 6, this would be a 3, and that will not work. Okay, so these are from 1, 2, 4, 8. So let's look at this again. This can't be a 3 because it sees a 4 by knight's move. And it can't be a 6 because this would be a 3, and as soon as this is a 3, it would put a 6 here where there's not a 6. So this is also from 1, 2, 4, 8. Now, I don't know that this can't be a 4. Don't listen to me. I know this cell's not an 8 because it sees a 7 or 9 by knight's move. So that's not an 8. And likewise, that cell's not an 8 because it sees a 7, 9 by knight's move. This cell's not a 1 because it sees a 2 by knight's move. Look at that, me actually applying the rules of the puzzle. So this is actually down to being a 2 or a 4, which is exactly enough to give us absolutely no information about this. This 7 or 9 also sees that that is not an 8. That 8 also sees that this is not an 8. So yeah, this is an interesting rule set that I have not seen before. The 7, 9 sees one more. I think I got it after you. I think you said that after I figured it out. Okay, so what on earth can go on this dot? So I can't actually put a 3 on this dot, because if I put a 3 on this dot, it will see the 2, 4. And the 3 can't see the 2, 4. So in fact, actually, by the most bizarre spot I've ever seen, 3 is hidden in row 5, because these cells see a 2, 4, and these cells see a 2, 4, and so the 3 can actually only go here in row 5. So that's rather large, because now this being a 3 tells me this is not a 2 or a 4, which tells me that that is a 1 or an 8. Why can't 3 go in row 5, column 2? Sorry, row 5, column 7. Oh, wait, sorry. No, you're right, sorry. Sorry, you're completely right. This 2, 4 doesn't see this cell by knight's move. I'm used to thinking knight's move just smashes both of these, but that's not actually how knight's move works, because I don't have the sudoku part. So what I actually know is that's not a 3, and I know this isn't a 3, but one of these 3 is a 3. That's what I actually know, and I don't think that tells me anything. I do, however, seem to have a 2, 4 pair in row 3, so that is a 1 or an 8. So what happens if this is a 1? If this is a 1, then that's a 2. But this has become a 4, 8 because of this being a 1. No, that's not how that works. Okay, but this is saying the 3 is either there or there. So I think I should look at that. The 3 is either here or here. It's in one of these two cells. Well, both of those cells do see this one. So this isn't a 4. I can at least say that much. Wait, if it's a 4... Sorry, if that's a 1, then 5 goes there. Well, the 5 would see that this was a 2. Or sorry, that this wasn't a 4. So that would be the 4. Oh, brother. Okay. So if this is a 1, that's a 5. This is Jessica's point. And so that's a 2. And now this would have to be the 4. I think that's okay. Yeah. It's just so ingrained that when I look at anti-knight stuff, I'm looking at those. That's already broken, though. Okay, so this is a 1, 5, 2, 4. But now this 4 has put a 3 here. I don't see how it's broken. Let's see. What's the location of the 3? Okay, Tristan is row 2, column 5. Oh, okay, so this was a 1. I see. Wow, that's weird. Okay. So I'm actually going to write this out just to show you what happens. If this is a 1, this is a 5. And now look at this cell. It sees both a 1 and a 5. So this digit can be neither consecutive with 1 nor a 5. And therefore it is no value. So that does not work. Okay. Good spot to all of those of you who saw that, because that is really hard for me to see. But I agree. Okay. So that's not a 1. Let's see. Ben has a good point. He usually does. The 2-4 pair on row 3 both see row 2, column 5 by knight's move. So it can't be a 1. That is a much easier way to see the thing that we just argued by a more complicated method. Yeah, but that is much simpler, so that is much appreciated. This isn't an 8, because it's in a box with an 8. I'm going to do that. 8 can't be on the white dot in row 5, says Panthera. Can it be on this one? Let's see. It cannot be on that one either. I spent far longer than I should have debating whether this cell could be an 8. We won't talk about it. We'll move forward. It's also in a row with an 8. This is true. This is true. That cell can't be a 6. Ah, that's right. This is an indexing cell, so I should look at this. Where is this putting a 3? So if this were a 6, it would be putting a 3 here, which would then see the 4 by knight's move. So it's not allowed to do that. So this can't be a 6. So this cell is now only odd digits somehow. So this cell can only be even digits. So this is a 4 or a 6. So if this is a 4, then this cell's a 4. If this is a 6, that's a 4. Okay. This is places a 3 here. If that's a 5, is that a problem? Sorry, if that's a 3, is that a problem? Not that I see immediately. And if that's a 3, is that a problem? Not that I see immediately. So I put a 3 here and a 4 here. That does put 2 self-indexing cells in a row. But I think that's okay in this puzzle. I don't think there's anything wrong with that. But someone was talking about that earlier. In a lot of these puzzles, you can't have more than 1 self-indexing cell in a row. But I don't think that's true here. You can get 4 in row 6. Where's 8 in row 5? 8 in row 5 is here. If row 3, column 7 were a 2, it would place a 7 in row 2, column 2, which would see the 8 by knight's move. Got it. Okay, beautiful. Beautiful spot, Chester. Okay, if this is a 2, that's indexing a 7 there, and that 7 sees that 8. That's not allowed. So therefore that's a 4. That's an 8. This is a 2. That's a 4. These are not 4. And ergo, they are 2 and 1. Okay, let's fill in all of that stuff. So this 2 places a 3 there. This 8 places a 6 here. This 4 places a 7 here. This 4 places a 3 here. This 2 places a 5 here. The 1 places a 6 there. Cheers, Kurabon. Have a great day, night, evening, whatever time of zone it is that you're in. I wanted to make sure, by the way, that I have conflict checker on, just in case it becomes necessary somehow. Okay, so that did a giant amount of stuff. Thank you for that spot, Chester. Let's see. So these are 7, 8, 9 are the cells that go here. So this 8 sees that cell, so it can't be a 7 or a 9. So this must also be an 8. Let's see. This row has a 1. We've got a 2, 3, 4, 5, 6, 7, 8, 9. Thanks for stopping by, Sam. Nice to see you, as always. This is not a 1, because there's a 1 in the box. This is not a 9, because it sees a 9. This is not a 1, because there's a 1 in the column. So that's the 1 by the magic of Sudoku. Let's see. If this were a 5, it would see a 4 consecutively. So that's a 9. That's a 5. also the 9 was in this box, or whatever other reason you would like to argue. There are lots of available options. Let's see. These are a 1, 2, 3. That's not a 1, that's not a 2. These are a 4, 5, 6. These are a 7, 8, 9. That's not a 9, that's not an 8. Panthera points out that 9 looks down, so that's a 7. I agree. Let's see. Yeah, this is... It's not surprising that this is going to be super roped. I bet it's going to be roped the whole way down, because it's so hard to come up with any grid that satisfies it. Like, if you'd asked me, could you come up with a grid where no digit is a knight's move from a consecutive digit, I probably would have bet on no. But as it happens, there is one, but it's probably the only one. Who knows? We'll see. It may not be roped the whole way, but that would be my bet if I were betting Zeta. This 4 sees this cell, so that's a 1. Let's see. This 4 sees this, so it's not a 5. This 7 sees this, so it's not a 6. This 7 sees that, so it's not an 8. So that makes that a 7-9 pair, which makes that an 8. This 3 sees over to here, so that's a 6. Row 2, column 3 sees things, I am told. Row 1, column 4, not a 4. Yes, sees the 5. Got it. Yeah, this 4, 5 sees that 5, so it can't be a 4, so it is a 5. So that's a 5 and a 4. Let's see. All right, so probably I can force this now. So if this were a 6, I would place a 4 here. Actually, that seems very plausible. If this were a 4, that seems okay too. Okay, what about this one? If this were a 7, it would place a 3 here. That actually looks okay. If this were a 5, it would place a 3 here. That actually looks okay. Let's see. The 5 in row 3 looks down. Yes. We had pencil marked 5s already, so that is a 5. I have no idea how I knew that. I knew that because I had this cell pencil marked. So in fact, as soon as that got filled in as a 7, I should have filled that in as a 5 and just didn't. So let's see. Row 2, column 1 sees... yes, this 6 sees that 7, 9, so that's a 9 and that's a 7. This is an excellent ranks puzzle. I feel like ranks would just absolutely love this puzzle. I will promise not to give him this as my gift for him. This 2 sees this 2, 3, so that's a 2. It's a 3. I will not just erase the setter name and replace it with mine. Okay, there's some 2s down here somewhere. Okay, we probably have to fill in just tons of digits. 3, 4, 5, 6. Sorry. 6 we need. We've got 7, 8. We need a 9. Okay, but this is not a 1 or a 2 immediately. This is not a 1 or an 8. Oops. This is not a 1 or an... Oh, there's not an 8 in the thing. It's not a 1 or a 6. These are not 9. That one's not 1. That one's not 3. That one's not 2. Okay, I'm going to look at these like a little bit at a time rather than sort of trying to do all of the stuff at once. So Let's see if anything sees any of these. So this 4 sees this cell, so this can't have a 3 in it. This 8 sees this cell, so it can't have a 9 in it. So this is a 6. So ergo, these aren't 6. So these are a 1, 2, 3 triple, so that's a 9. So let's see. Where is this 2 sees this 2, 3, so it's not a 2. So it's not a 3. It is a 2. 1, 3. Okay, so this is not a 3, by the way, anymore. That is now off the table. Let's see. What is left in this box? That might be the smarter thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's just look at columns first. That's not an 8. This is not an 8 or a 9 by the row. Okay, so now the 8 sees this. So this is a 3. These aren't 3 anymore. Thank you, computer. So now this 7, 8, 9 immediately resolves that that's a 7, because I have to place a 7 over here. So that's a 7 and that's a 6. Let's take that 7 as placing the 3. And that 6 is placing the 4. And then what's left is a 5 in the row. Okay, that 9 looks here and says that's not an 8. It's a 7, 9 pair, so that's the 8. That 6 looks here, so that's not a 7, so it's a 9 and that's a 7. That 7 looks up and sees that's a 9 and that's a 7. Let's do the rest of... Yeah, I love the backwards row. Let's see. 2, 3, 4, 5, 6. Okay, so now this is not a 1. This is not a 2. This is not a 3. That 3 is not going to do it, but this 2 will. This 2 looks at this and says that that's not a 3, so that's a 2. 1, 3. This is not a 4 or a 5 or a 6. This 5 looks here and says this isn't a 6, so it is a 5. 4, 6. Okay, so now we get to do the columns. So let's just pencil mark these. 1, we need a 2. We've got a 3. We need a 4, 5, 6, 7, 8, 9. So that means, yeah, we've got these things are roped, so this should be easier than I am making it. So these are 1, 6, 8. These are the other one, 3, 5, 7. Okay, 2, 4, 9, 2, 4, 9. These are 2, 4, 9. 1, 6, 8 go here. 3, 5, 7 goes here. Okay, 1, 6, 8 goes here. 3, 5, 7 goes here. 2, 4, 9 goes here. By the way, if you're curious what this roping business is, whenever it happens in any Sudoku puzzle, that if you look at one column in one box and see, for example, it's 294, and you see those digits repeated in a box below or above it in the same column, it actually forces immediately, well, just by Sudoku, that these are the same 3 digits. But then actually it does more, because it actually forces that the same thing is true of the other 2 columns. So as soon as one column repeats like this, you then are guaranteed that you'll get the 186, 186, 186. Sorry, I did not highlight well. And then you'll get the 357, 357, 357. And that's called roping. And it happens in rows as well. When it happens in columns, I think they're called stacks. And when it happens in rows, they're called bands or something like that. But it's a pretty cool thing that happens that you can utilize to your advantage if you are so inclined. Okay, so now hopefully we can finish the puzzle from here. Surely something sees something. That is my my hope, is that if something sees something, that will help us finish the puzzle. This 2 sees that that's not a 1. I can at least do that much. Listesh has a really great puzzle called Extreme Roping that is just ropes all over the place. It's very cool. Okay. This 6 sees that this is not a 5 or a 7, and so it is a 3. Gorgeous. And so that's not a 3. That's not a 3. That was Chester's point. Chester has been indispensable in this time. This 3 sees that this is not a 2 or a 4, so it's a 9. So these aren't 9. These aren't 9. This 5 sees that this 2, 4 is not a 4, so it's a 2. And that's a 4. So these are not 2. These are not 4. These were supposed to be not 2. Okay. The 9 here sees that that's not an 8. Let's see. J40 says, betting that box 1 and box 3 will be completely identical. Sorry. Box 9 will be identical with box 1 and box 3. Box 5. I was very confused. Yes. Very clever to note, actually. These are exactly the same. And so, yes, I will bet with you. I think that this probably will turn out to also be exactly the same. Let's see. Row 7, column 1 says Logan sees that this is not a 6. And it also sees that 8. So this is, in fact, a 5, and that's a 7. This 7 sees that that is not an 8, so it's a 1. So these aren't 1. This is now a 6. That's an 8. So not 8. That is an 8. That's a 1. Well, off to a good start on your bet, Jay. So let's see. That 1 sees over that. That's a 6, and that's a 1. That 6 sees over that. That's an 8, and that's a 6. So we've got all of that sorted out. This 6 sees that this is neither a 5 nor a 7, so it's a 3. So this is not a 3 anymore. There is a 5 already in the row. So just by regular Sudoku, that sees that that's a 5 and a 7 and a 3. Not necessarily in the order that I said. So that's not a 3 or a 7, so it's a 5. So that's a 7. Let's see. Okay, so now we just have to sort out this last bit, which I'm sure is being seen by something. This 5 sees that this is not a 4, so it's a 2. And that will unwind the rest of this. And there we go. Yeah, this kind of puzzle is fun to do every now and then. So I'm assuming... I don't think JC Godart is here, so I don't think they can confirm. But I'm assuming this required a computer to set. Because I'm guessing there's probably very few grids that satisfy this. You probably need one to find this. But maybe with the fact that it ends up banded in 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe it's possible that you could guess this by hand, but oh boy, I would not want to. Yeah, puzzles like this end up having a very different feeling to solve than the typical, like, handcrafted puzzles, because they're sort of like, you're exploring, like, a crystallized logical formation that exists almost outside of having been set. Like, it's more like the setter discovered it than the setter it's more of a discovery than a construction. And those are very fun, but they have a very different flavor. Like Ransk has one, I think it was actually for Jessica's birthday, that I tested, where it was like no digit can see itself within a taxi cab move of 4 or something like that. So it was like, this digit can never be the same as this digit, this digit, this digit, or whatever. And so it was something where it was definitely found by a computer, but it was unique. And so it was interesting to sort of pick it apart and watch it fall apart. And they tend to a lot like this one, sort of like once you make the right insight, which was this 4, once that you make the right insight, then they all just collapse and everything sort of falls up. But yeah, I've talked a lot about my feelings about global constraints. But yeah, for global constraints, you kind of need, especially global constraints this strong, I think you need to do them with computers as help. Although Panthera says she would do this by hand, I would not envy her doing. Took a while to sort of get my head comfortable with anti-night non-consecutive, but once I got there, that was it was pretty natural and was interesting, and I'm a little sad that I will probably never again get to do an anti-night non-consecutive puzzle, because probably this is the only grid that has an anti-night non-consecutive property. Oh yeah, absolutely. Tools are great. None of what I said should be considered as disparaging the use of tools. I think tools are great, and they let you come up with a bunch of different things, and puzzles that have a very different feel. Like if you look at my puzzles, there's definitely, like, I think the one that I have that's closest to this is 2D wave particles, which is just an absolutely absurd grid that it exists that I don't think I would have ever found without the help of a computer. But it's very, very few. Like, it is probably the only puzzle I have where I could reproduce the grid verbatim on a blank sheet of paper without looking at it at all. Because the grid is just so simple. But again, like, it gives you a very different feeling when you have to sort of pick apart. Like I said, I like the analogy of a crystal. I don't know why. Mathematicians like crystals. It's like being some sort of crystallized structure where it's completely rigid. There's absolutely no give whatsoever in the structure of the puzzle. And those are cool. Like that's how I would describe this, and that's cool. And then the sort of the absolute opposite from earlier in the stream, where I am going to bet no computers were involved in the setting of this, because I think you could make this come out to almost any shape you wanted, and there's lots and lots of give to it. And so as a setter, it's very easy to set it up so that you don't accidentally box yourself into the grid having no solution or whatever. Relatively easy, I should say. All right, well, I should probably wrap up the stream there and go have dinner. Oh, I'm sorry that sorry, I was looking at this and saying, oh no, I have the rules, or have my camera covering the rules, but that's because this isn't the puzzle we were actually doing. In this puzzle, I don't think my camera covered the rules. You don't like crystals because they remind you of optics. Was that a traumatic course for you as part of some sort of physics program? See ya, Panthera. Thanks for dropping by. Sorry my stream times don't always work out the best for you. I know we are always 2 ships passing in the night. Yeah, today was a very cool collection of puzzles. Oh god, I should say it's like mercury rising in a thermometer, and it will make as much sense as when Simon says it. That's a good idea. Yeah, so going into high school, I sort of imagined I was going to be a science major eventually, and then I discovered how much I hated doing lab work. And then I was like, okay, I'm never going to survive undergrad, much less grad school, if I have to do this constantly. So I managed to basically avoid taking lab classes through all of undergrad almost. Uh, but yeah, the uh, lab work is not something that works well for me. Uh, Compliments to all of you. I know there are lots of you who work in lab related fields. Uh, Although apparently there's lots of math people in the Sudoku community also. That is what we learned earlier in Rank's stream when he was taking a survey of how many people had a BS, MS, or PhD in math, and it turned out that like something like a third of the people watching did. Anyway, I'll wrap up the stream there. But I will see you again on Wednesday when we will do more fun puzzles. And don't forget, if you're interested in the challenge, you've still got a chunk of time to do it, but the challenge is to set me a Sudoku puzzle with no fives. All right, I look forward to seeing what you all make. And I will see you all on Wednesday.